And then you go inside the system for logical and physical architecture. Okay, so logical and physical architecture, the distinction is a recommendation also by the INCOSY, for instance, and by a lot of systems engineering methodology. So logical architecture, you don't yet define the concrete physical components. You begin to break down your system into so-called logical virtual components. And the idea is that you will group functions according to typically non-functional criteria, such as performance, safety, security, product line, and things like that. And then, of course, at physical architecture level, you really model the physical components, so how the system will be built. Okay, so in Arcadia, you have concepts, you have syntax and semantics to describe all these levels, and the Capella tool enforces really the distinction between these levels, which is very important. And also, very important, you have some traceability links between these levels. For instance, you will be able to say that something at physical level will realize something at logical level, realizing something at system analysis level, and so on. So by putting the traceability links into the Capella tool, you will be able to edit matrices, completeness matrices, and so on. And the tool also does some model checking and emits warnings if something at a given level is not realized below. Okay, so Capella is a tool. So I was maybe a little ambitious in my work to go down to physical architecture. I think that in 1.5 hours, if we already do a lot of things at system analysis level and logical architecture, it will be nice. You have to know that the usual training that I give inside Thales, for instance, lasts 3 days, and all the people find it very short. So to know about Capella, you need 3 or 4 days. So in 1.5 hours, I'm not really sure, and with a lot of people. But okay, we will try. So Capella is a modeling tool. The difference with the other modeling tools is that it knows perfectly Arcadia, so both the concepts and the diagrams that Arcadia proposes, and also the distinction between the different abstraction levels is very strongly indicated in Capella. And also you have some predefined tooling enabling you to begin a certain level with concepts that were described at an upper level. So there is some automatic initialization of a given level from an upper level. Capella is a modeling tool, so of course you will need to link it to other tools, maybe with simulation tools, maybe with software modeling tools, maybe with upstream architecture framework tools, and so on. So of course Capella for the moment is the Capella that you have downloaded and installed on your PC only enables to model Arcadia levels, but there are some additional and complementary tools to link, for instance, model elements with requirements. That would be in another tool, to generate documentation, and to provide bridges with more classical UML or SysML tools, for instance. There are also additional tools called viewpoints. So the basic Capella tool enables you to do what you could do in UML or SysML. If you want to do performance analysis, safety analysis, you need to add, in fact, additional complementary little tools to deal with these specific aspects. Okay? So the idea is to be able to add viewpoints, and maybe the next workshop with Sirius will show you some ideas about this. And these additional and complementary tools, of course, are very contextual to the project, because the performance viewpoint on a project dealing with satellites is probably not the same as a performance viewpoint for people who deal with ground transportation and things like that. Same for safety. So in fact, Capella is very open, and you can define with Kit Alpha and Sirius, you can define additional complementary tooling quite easily and efficiently. So the purpose of the workshop is to show you how to use the core of Capella, and already it would be nice. Okay, so it's a hands-on workshop. So I will start Capella, and I have a little scenario to try to build a little model for a simple case study. But even with a simple case study, you will see that, okay, we have to do diagrams, you have to build diagrams, so it will take time. So the constraint will be time, in fact, okay? And we will try to see the main features of the tool while we will model. So the idea is to launch Capella. Okay, the latest version is 0.8.1. So Arcadia is inside, you can see it quite easily. So just before beginning, how many of you have already used the modeling tool, just to have an idea? Yeah, okay, fine. Okay, so here I cheated a little because I have a project already open. Okay, I close it. I can close even this. So let's begin with an empty page. Should be your case. So the idea is to create a new Capella project. Capella library is something to be able to reuse components or data modeling and things like that. Okay, I'm not used to use a mouse on a slope, but okay. I can't do modeling with a touchpad. Yeah, it's impossible for me. Okay, so you have to name your model. Okay. If you click, is it good for those who want to do it? So you can do it, of course. You can do the same as me. I will not maybe wait until everybody has finished, because you are too many, but we'll try to do it together. If you click on Next, the tool proposes all the 5 Arcadia levels, and in fact, operational analysis and EPBS are optional. If you know from the start on your project, you will not do any operational analysis, or you will not describe EPBS in the tool, you can already uncheck them. Okay, let's keep everything. And when we click on Finish, in fact, the tool creates an empty project, but it's not completely empty. And what's very important is that you can see this overview here. This is a diagram. You can click on any of the 5 abstraction levels. And of course, in fact, you can begin with any level. You're not obliged at all to do a top-down approach. If you are dealing with an existing project and you want to change the physical architecture because you have a new technology available, you can begin at once with physical architecture modeling. Okay? For this workshop, I will do it top-down, as if we were in a new project from scratch, which is seldom the case in industry, and also because there are some tooling that are available in this case and are not available if you do bottom-up or middle-down, middle-out. Okay, so you have a predefined template, in fact, in the tool. If you go to the Project Explorer on the left, you can see that there are already some so-called packages or folders. Okay. For instance, in the system analysis level, you have already something that represents the system as a black box. Okay. In operational analysis, you don't have any system. At logical architecture, you have something that will represent the system at logical level, and where you will put inside your logical components, for instance, and so on. Okay. You can also see that there are some different colors. You have orange here, green here, and so on, gray. There is a predefined color map, which is very also practical. As soon as you see orange rectangles in Capella, once you're used with it, you know that it's mandatorily operational analysis and, in fact, operational activities. As soon as you see green rectangles, you know that we are speaking about functions, for instance. And when you see blue rectangles, you will know that we are speaking about components, something like that. Okay, so let's begin with operational analysis. So if you are not familiar with Arcadia, there is a little reminder of what is the goal of operational analysis, is to define really the needs. System analysis is really to formalize system requirements, and so on and so on. And when you click on one level, in fact, the tool will provide you a more detailed methodological guidance, once again, and will ask you, what do you really want to do? Do you want to define operational entities, things that exist in the world? Do you want to define behavioral concepts like activities, for instance, and data flows between activities, sort of business process modeling? Do you want directly to mix activities and entities? So allocation is a very, very important concept in Arcadia and Capella. You have behavioral concepts at each level. Activities and functions, for instance, are behavioral concepts. You will have structural concepts on the other hand. So the system as a black box, the external actors, the logical components, the physical components, and the operational entities are structural elements. And a very important thing is to allocate the behavior to the structure. Very classical in system analysis, system engineering. So at each level of Arcadia, you will have the possibility in a specific diagram to show this allocation by embedding rectangles into other rectangles. And of course, you can do it with property sheets or with matrices. As in any modeling tool, there are several different ways to do the same thing, to express, to create model elements or to create relationships between model elements. There are often 2 or 3 or 4 different ways to do it. Okay? So when you're used with a tool, you take habits, depending on personal choice, you will choose one way to do it or another one. Okay, so the example, I forgot to tell about the simple case studies that we will work on together. The simple case study is a very, very complex system called a clock radio. Okay, so probably you have one in your bedroom or not. Maybe you use your smartphone now, but okay. Clock radio is nice because you have some projection. You can have some projection of the current time on the ceiling, for instance. Okay, so clock radio is a system. Okay, we can specify it with system analysis, we can try to imagine, because I've not broken my clock radio personally, but we can imagine which are the internal components. And we could even go back to the real need. Why do we need a clock radio? So that's the aim of operational analysis, in fact. So why do we need a clock radio? What are the activities that are done by somebody or something that could be helped by a clock radio then? So to express this, okay, we will not do a lot of different diagrams. In fact, I want to show you before, for each methodological topic, the tool proposes several different possible diagrams. Okay? So in fact, already at operational analysis level, you have around 9 or 10 different possible diagrams. So we could say that for Arcadia and Capella, in fact, at each of the abstraction levels, you have 10 possible diagram types you can use. And of course, you can do several diagrams of the same type. For instance, if you look at the scenario type, usually people describe several scenarios, maybe a lot of scenarios, depending on what they want to do. Okay, so it's as rich as UML and SysML, but at each level. So you can multiply it by 4. EPBS is a little less rich, in fact. So 4 times 10 diagrams. So that's why, anyway, you will need to choose which diagrams you will use at each level, depending on your project. Of course, if it's a clock radio, you will probably use less diagram types than if you model a satellite constellation that will last 30 years, probably. If you don't, you will never produce a clock radio, probably. Okay, so let's try directly to think about entities and activities. So we will create what is called in Capella an OAB, Operational Architecture Blank diagram. I will try to explain in the time that I have the main difference between the blank diagrams, the scenario diagrams, and the breakdown diagrams. So we could change the name, but we have no time. Okay, let's just close the rules and accelerators. Accelerators are very interesting little tools when you master the tool and you want to go quicker. But when you're a beginner, it's better not to see them, not to look at them. So in an operational architecture blank diagram, we want to describe who does what. So who will be entities or actors, and what will be activities. Activities can have data flow linking them, which are called interactions. And we will allocate activities to entities and actors. Okay? So the idea here, so just give me an idea of what is a real need. Why do we want a clock radio? To get time? Yeah. What else? Try to express activities with active verbs and complement. Wake up nicely. Yeah. Maybe to listen to radio when in bed also. Okay. So we could imagine several different operational activities, and who will do this? Is it an organization? Is it somebody? Yeah, anybody. So I will create an operational actor. It's a little stick man. So an actor is a human entity, and an operational entity is any other entity. An operational entity can contain other entities. An operational actor cannot contain anything except activities. So the operational actor here, I will call a person. I can already change the name directly. Okay? So a person may want to wake up. Okay. or may want, just by putting an activity inside the operational actor, I already allocate the activity. So in the tool, in the model, in fact, there is a strong allocation relationship between the activities and the entity, okay? Just by putting it inside. Wake up, get time, and so on. Listen to radio, and so on, okay? Okay, of course, you have some graphical little things. Ooh, nice. Okay. So now if I want to go a little further, I could say that this person is inside a room. Okay, I can put a room here because it's a clock radio, a domestic clock radio. And if I put my person inside the room, in fact, here again, there is a semantic link. Here it's a containment. Okay, a structural element can be contained in another structural element, but a behavioral element can be allocated. Okay, semantically, these are different. These are different relationships. So I just stop here. I could put the room in a house and so on. What's interesting is that this is one type of diagram. If I want, I can ask the tool, okay, I would like to have a simplified view of my model, just which are the entities and actors, just the structural elements. And I want to describe a breakdown of structural elements. In fact, the breakdown diagrams in Capella are always up to date. It means that because I've already created structural elements with a containment relationship, the tool, in fact, will provide me with a diagram which is not empty, okay? You already have, the person is inside the room, okay? So breakdown diagrams are always other viewpoints, another viewpoint on the model, but they are always up to date. And for instance, if I decide that my person is not inside the room, so if I just get the rectangle out, as soon as I open again the breakdown diagram, okay, the containment relationship has disappeared. Okay, so for people who have already used a modeling tool, no big surprise. But a lot of people that use Capella inside Thales, for instance, are system engineers that mainly used PowerPoint, Visio, Excel, Word. So they are struggling with the consistency of the diagrams in PowerPoint and so on. So for them, it's a very strong point, of course. Okay. Okay. Just a little look at my scenario. Okay. Yes. Okay, in the scenario, I had the house also. Just, yeah. On the Project Explorer on the left, in fact, you can see that you have created some activities, you have created some entities and actors, and so on. Okay. The Project Explorer on the left is the usual tree view of the model, which is not very good. A model is not a tree at all. A model is a graph of connected elements. So in fact, in Capella, you have a very interesting tool which is called the semantic browser. The semantic browser enables you to browse inside the model independently on each specific diagram. So for instance, okay, in my breakdown here, oh, by the way, I will show you something. In my breakdown here, I have the room, I have the person, for instance. If I click on the person here, it tells me that there are two activities that are allocated to this person because they were allocated in this diagram, of course, okay? So this is a view of really what exists in the model. This concept in the model is linked not only to this diagram, by the way, it appears in two different diagrams, but it has a location going to it. By the way, there is a nice feature of the tool. Undo is working very well. So I undid first the move, then the delete of the containment. I undid it on this diagram, but in fact, of course, it was undone at the model level. Okay, so the undo works not only for graphical features, but also for model modifications. So it doesn't work so well in all the SysML tools, for instance, that I know, by the way. Okay. Okay, so the room here has a breakdown. The person is inside the room, and the person has activities allocated. Okay, so for operational analysis, probably it's sufficient. And in fact, the idea is that we could try to define a system that meets these operational activities. Could be probably a smartphone. With a smartphone, we can get time, wake up, and get news. Okay? So operational analysis level is interesting for that. It opens the possible solutions, in fact. We are not yet stuck with one specific system. So that's also why operational analysis is optional. Of course, if you are working on the 20th revision of a radar, maybe you don't have to spend time on why do we need a radar? Okay, we've been doing radars for 20 years. We just want to modify physical architecture because there is a specific request from one customer. So maybe we can begin with system analysis at once. Okay, depends. Okay, system analysis level here, we will speak about the system. So we will name the clock radio. It will be a box. It will be a black box. In fact, in Capella, it's a blue box, by the way. And inside the clock radio at system analysis level, we will not define any internal components. We will only define functions. Okay, requested behavior. Okay, it's external functional analysis, in fact, at this level. So we'll define functions that the clock radio must perform. These functions must be understandable for users, for end users. Okay, it's the end users that should point these functions. It's not internal technical functions yet. Okay, internal functions will be at logical and physical architecture level. And another important thing is that at system analysis level, we want to define precisely the external interfaces of the system. Okay, so very classical thing in system analysis. What is the requested behavior of the system, and what are its interfaces with its environment? Okay? So we have several possible diagrams to express it in Capella. We will try to begin this one. Okay, it takes some time to draw a nice diagram, especially when I have my mouse like this. So maybe you will do it quicker than me. So the idea is to define, I put it once again, is to define, okay, what does the external human user want to do? Okay, he wants to get time, but not only, in fact, to get the proper current time, he must be able to set the current time if, for instance, the clock radio is shifting, or if there is a summer time or winter time and things like that. He or she wants to be able to set the alarm time to be woken up at the proper time, and maybe to change the frequency, the volume of the radio, and so on. Okay. So these, in Arcadia, you will model with functions. There will be functions inside the external actors, enabling to have flows, functional exchanges, between the actors and the system. In fact, the information that flows from the actors to the system and from the system to the actors are considered to be best captured if you take the time to identify functions. function is active verb and complement. Okay? So of course we will not model in detail the external actors because we are interested in the system, but it will enable to have more confidence on the completeness of what we can define as external interfaces. Okay, so let's try to begin it. I have a look at the time. Yeah, so to do this, we go back to the overview. Well, we can close. I have a small screen definition here, so I will close this. I will close the OAB, by the way, also. And now, in the overview, I go to system analysis. Okay, now I want to deal with system analysis. I just forgot to show you something. Here there is a diagram viewer. So it's automatically updated on the right, and it will show you all the diagrams that you did at a specific level, and they are all classified automatically by the tool. And you can double-click on any diagram to open it again. Okay, at system analysis level, nothing yet, normal. Okay, if the functions that will be in the system are very similar, or some are very similar from the operational activities, we could even use this little tooling. We will do it, if we have time, for logical architecture more. We can do the same for the external actors at this level that can be created from the operational entities and actors, and so on. Okay, here we will create new things. So I will show you how to create the traceability links. So I want to, because I have not much time, I want to create directly a system architecture blank showing both the system and the actors, external actors, and functions inside. Okay, system, okay. Maybe I could rename already the system. There is a concept called system in my model. But for me, the system is a clock radio. So I can rename it. So now, in the tool, when I ask for a system architecture blank, in fact, the clock radio name will appear automatically. Okay. And also, when I will use the clock radio in a scenario diagram, it will be named clock radio and not system. Okay. So once again, in this kind of diagram, you can use both structural concepts and behavioral concepts. So it's a blank diagram, so it should be empty, except that the tool knows that at system analysis level, if you don't show the system surrounded by its actors, you miss something. So the tool inserts it automatically. Okay? So as I have little space, I can double-click on the tab to be full screen. If you double-click again, you see again the project explorer, the semantic browser, and so on. So while you are modeling, usually you use a full screen thing. Okay, let's create a new actor at system level. Okay, here I will call it user. It's not any person, it's a clock radio user. So I create an actor, a system actor now. It's not the same concept, okay? At each level of abstraction, you have different modeling concepts, and they will be linked by realization links. Okay, so you can keep your operational analysis as it is, and then work on system analysis. You can keep your system analysis level and then work on logical architecture, refine functions, and so on. Okay, so that's very important. I could say that this user at this level, in fact, is linked by traceability with a person operational actor that I define in operational analysis, or that somebody else defined in operational analysis. To do this, for instance, I just double-click on the actor, and it proposed me, okay, I have only one actor at operational level. So here I just put a traceability link from a system actor to an operational actor. This traceability link, by the way, if I go back, should not have closed my OAB, for instance. If I go back to my OAB and I click on my person at operational level, you see now that the realization link from the lower level is shown by the semantic browser. Okay? Semantic browser tells you everything about a model element. All the links that it has with all model elements, even at different levels of abstraction. Okay, so the user wants to do things. Okay, I'm not sure we can do all this, but for instance, get time. So we put a function here, we change the name. Okay, to have the time, the clock radio must display the time. Okay, there is a function, that should be a function, a display function in the clock radio. I'm not doing design here, I'm just expressing requested behavior. The clock radio must be able to display time. Okay. And I want to express that there is a functional exchange between these two functions. Could be current time. Something like that. Okay, let's focus. It's already 9:45. Let's focus to set current time, for instance. We want to be able to set the current time. Okay, so do we distinguish here a function that displays and a function that manages? Maybe. Maybe we could do it at logical level or physical level. Okay, it's a choice, of course. Okay, let's do maybe something very simple. Okay, I can create a new functional exchange. I can say that this is new time, new value. Okay, up. Like that. Yeah. New time and so on. Okay, I want to be able to be woken up, so I want to wake up. So at least we will model an alarm going out. So the system must trigger an alarm. That's a very important function of this system. And the alarm will go this way. Okay. Of course, probably the time, the current time, so display and manage here, I've simplified. So the current time will have to go to the trigger alarm function. So there will be a functional. Okay. I oversimplify. Okay, something like that. It's not a technical choice yet, okay? Probably at logical and physical architecture, I will refine these functions because user interface management will be in a different logical components from the internal management of the time. There will be a clock and so on at physical level and so on. Okay, and there is probably, so you can save. There is no automatic save, okay? So, okay, this was, the aim was to do this, but over-ambitious. So the idea is you have something that manages the time, manages the alarm. You can set or unset the alarm. You can set the alarm time. Of course, the tool, the product, the clock radio, should be able to broadcast radio and to emit sound. And it should be able to receive radio waves emitted by another actor. Okay, I don't have time to do it on hand now. Okay, the idea then is that all these functional exchanges that we identified help us to identify the need of exchange between structural elements. So for instance, here, we need some user commands. So we need to put a component exchange, user commands. We could group under this component exchange, set new time, set alarm time, and so on and so on. So here, I will just allocate, it's also allocation. I will allocate a functional exchange. Okay, it provides all the functional exchanges, but here I just want the things that go from the user to the clock radio. Okay, I could put it here, it would be nicer. And then, okay, I will create one component exchange for the current time, which is a display. So here I have some display info. And this info, in fact, here it's only the current time. And I will have some audio, an audio link. Okay, the alarm, the radio sound will go through another component exchange. So it could be interesting to distinguish between these because of non-functional requirements. On the display, it's very different from the audio. So all this can be linked to requirements, of course. Audio things. Okay. And here I would put both the alarm and other things. I allocate. By the way, you see that each time I allocate something, it is removed from the selection list, in fact. So that's very interesting in terms of methodology also. So here I have allocated, I think I have allocated all my functional exchanges. Because I have only 3, it's easy to see. Imagine I have 20 or 30 functional exchanges. The tool provides some filters. Here you have some filters. And for instance, we can say hide allocated functional exchanges. So if there is no remaining functional exchange going out or inside the system, I'm sure I've allocated everything. There is an internal functional exchange, but I can't allocate it to a component exchange with an external actor. This will be allocated probably inside my logical or physical architecture if it crosses components. But at system level, it's nice. Okay, so there are filters that you use while you are modeling, and there are filters that you will use also to give simplified views of diagrams. So here, for instance, imagine that the diagram is considered to be too complex. Okay, not really the case, but so it's very easy with the tool to go back to the overview, system analysis, diagram viewer, and here I can ask the tool, clone the diagram, because I want to have another view of the same thing, but maybe for my boss or for the customer, he doesn't want to see both the functional and the component exchanges, the port allocation, little things here, the port, function ports, component ports. So here I will filter. I will say, okay, what I want to see is only the functions that are inside the clock radio, not the function inside the user, and I just want a simplified view of this. So for instance, I could hide all the functional exchanges. I could collapse the function ports. I could even hide these 3 functions specifically and keep these ones. And instead of putting the names of the component exchanges, maybe I want to precise the names of the functional exchanges that go through, especially if there are several functional exchanges going through the same component exchange. Here it's one-to-one, but so there is another filter here. I can show allocated functional exchanges on component exchanges. I have to refresh the diagram. Okay. So here it's the name of the functional exchanges. So this is a simplified view that maybe will be in the introductory chapter of the specification document for my clock radio, showing only requested functions and external interfaces. Okay, this one is more complex. Maybe it will be in another chapter of the document or in another document, and so on. So it's very easy to do different views of the same system. Okay, it's a modeling tool. So there is an underlying model, and the diagram is just a partial view of the system. Each diagram should have a clear objective and predefined readers. Okay, the reader for this diagram is not the same as the reader for this one. Okay, just we can have a look at the Project Explorer. We have created functions, data flows, we have created actors, and so on. We have created component exchanges. So depending, this can be parameterized. So maybe with the default parameters, maybe you don't see the functional exchanges and the component exchanges on your Capella version. You can change it here. Okay, it's a little tricky. Okay, nearly 10 o'clock, so let's proceed. So that was a complete one, little more complex. And a simplified view, okay, with filters. You clone the diagram and you can apply a lot of different filters depending on what you want to show to whom. Okay, traceability is important, so I showed you how I put a traceability link between the system user and the operational actor person. We can do the same for the functions and the activities. So for instance, what we can do is, okay, we can directly double-click on one function and put a realization link, get time, okay. And same for wake up here as a link to the wake up activity. Okay. Then imagine I have a lot of functions. If I want to have a synthetic view of this, a matrix is very interesting. So at system level, you can create a matrix with the functions at system level as lines, rows, and the activities as columns. Okay. And this matrix represents the current state of your model, but of course you can edit it. So for instance, okay, the display time function, well, probably it participates to realizing the get time activity also. So if I want, I can put an X here, and this modifies the model. Okay, it creates now another realization link. Set current time, well, maybe also to be able to get time, I have to be able to set the time, and trigger alarm will help to wake up. Okay, so I can modify, complete my traceability links in this kind of matrices. Of course, if I go back to any diagram now, for instance, the operational architecture blank, and if I ask the semantic browser, tell me which are the functions at system level that realize this activity, now they are shown on the left. Okay, the semantic browser really shows you everything about one modeling element. Okay. Okay, a very important kind of diagram is a scenario diagram. It's sequence diagram in UML and SysML. Very widely used at system level to describe black box scenarios. It will help to describe validation tests, something like that also. So at system level, I can create what is called an exchange scenario. So let's create a very simple one. I will call it alarm, because I didn't create a lot of functional exchanges. It will be very simple, but okay. Once again, the tool knows the method. Because you are at system analysis level, the tool knows that if you describe scenarios that don't show messages going either to the system or from the system, you've missed the point. So by default, the system itself is put graphically in the scenario. It's only at system level, at logical architecture level, you may describe scenarios implying any subset of logical components, so the tool can't guess. It's only at system analysis level that the tool is sure that you have to put the system in your scenario. But you could have only a subset of the actors for a given scenario, so the tool doesn't guess. You have to put, you can create a new actor, or you can insert existing actors. So here we have already one actor, the user. So we just insert the user in the scenario. Okay, of course, it's the same user as the one that is on the SAB. And of course, if we rename it, it renames everywhere. Okay, so if we need to put a message here from the user to the clock radio, the tool proposes the existing message. So by the way, new time, okay, I would like to set the alarm. So here I realize that I've forgotten something in my SAB. I've forgotten the set alarm, put the alarm on message, which is very important. I don't want to be woken up on Sundays and something like that. So here, the tool displays the available functional exchanges, but I can go to creation mode. And I can create a new functional exchange, alarm on. A functional exchange in Arcadia goes mandatorily from one function to another one. So the source function should be inside the user. So the tool tells me inside the user you have get time, set current time, and wake up. Okay, maybe I would need, in fact, a new function called set alarm parameters. But okay, let's use the wake up function. And the target function is mandatorily inside the system. So okay, it's more the trigger alarm. Maybe I would need a manage alarm function. And here, in fact, I've not only created a message on the scenario diagram, I've also created a new functional exchange between existing functions of the system and the actor. So if I go back to the SAB, you see that there is a new alarm on message here. And by the way, if I apply the filter hide allocated functional exchanges, there is a little problem. I need now to allocate my new functional exchange to a component exchange. Okay, it's a user command. So I will allocate this new functional exchange, it's the only one available, to the component exchange. Okay, if I remove the filter now, okay, my diagram is a little more complex. And by the way, my simplified diagram, there should be two functional exchanges on the same link. So let's check. Okay, now you have two with a comma. You have two functional exchanges now that go from the user to the clock radio. Okay? So for people who are fond of sequence diagrams and thinking in terms of scenario, you can, of course, illustrate your model with scenarios at each level, but you can also create new anything. You can create new structural elements, you can create new functions, new functional exchanges, and so on. Yep.
I missed how does the tool know that this functional exchange is the wake-up function of the user?
I chose. I do it again, just. In fact, if I create a new functional exchange, first the tool knows that the source is a function that must belong to the user, and the target is a function that must belong to the clock radio. So if I create something, I chose. That's what we missed. And I could even create a new function just by typing a name. And this function would be automatically allocated to the user. So it's very, very powerful. Okay, I can cancel. Yeah. Alarm on, and let's say that at a given time, there should be the alarm. Okay. Maybe I could add that anyway. The current time is displayed before. Okay. Very simple scenario. So on the evening before alarm on and in the morning. So we could put some constraint. Constraint is something that must be true, saying that at the alarm time, so I will show you on the slides completed diagrams. I will post the slides, of course, after the conference. So you can use combined fragments like in UML and SysML to indicate optional things, loops, alternatives, parallel, and things like that. In fact, you have all the power of the UML2 sequence diagrams here. Okay. States and modes are very important for system engineers. What are the modes of the system? Is it in manual mode, automatic mode, semi-manual mode? Is it operational? Is it in a degraded state? Definition of modes and states is a little variable depending on the people. So in Capella, you can create. Oh, we always go back to the overview. The overview gives us all the possible diagrams. So at system level, I would like to create a very simple state and mode diagram for the system. Create a new mode and state machine. In fact, you can create mode and state machines on each structural element, including the external actors, which can be useful if the external actor is an existing system and you know the states of this system and which functions are available. It has an impact on your system. It can. Okay, here I want to describe some modes of the clock radio. Okay. So here again, you have something that looks like UML2, SysML state diagram. Not complete, but improving. Modes and states are different words, but in fact, they are treated the same as UML states, in fact. So let's create, for instance, init mode. What was the ID? Well, radio off, on, and auto. Yeah, it's better. So the radio of the clock radio is either off, on. Okay, I want to listen to radio. Or auto means I've set the alarm and I want the radio to automatically be produced. Auto. Okay, I can have an initial state, off, transition, and so on. Okay, I can create a lot of transitions, of course, and so on and so on. Okay, I will just show you something interesting. For instance, here, from off to auto, let's say that what triggers is that the user puts the alarm on. Okay, So here's the trigger. In fact, I could type text, but it would be not linked to any model element, or I could say the trigger is really the alarm on data flow. Okay. Okay, this way, if I ever change the name of the functional exchange in any diagram, it will be changed also in the state diagram. Okay, things like that. Inside auto mode, I could have a silent state and a ringing state. Okay, we can put states inside modes, modes inside states, and so on, depending on how we define states and modes. Okay, and of course, there will be transitions between these and so on. Okay, it could be like this. Simplified view of a clock radio, but with a timeout. Maybe it rings a few minutes and so on. So what's interesting now that we have defined some states and modes for our system is that we are able to link these states to functions. We can say which functions are available. Okay, display time is available everywhere, but trigger alarm is not available if the clock radio is on, is with radio on. It's only when it is auto that, okay, all the functions are available here. And when it's off, well, of course, the display time is still available. Okay, so I can do it from this. I could also have double-click on one function and edit the list of mode. And there is a third way to do it. I can edit a matrix once again. Okay. The other thing is that these modes and states, I can use them also on my scenario. I could say, for instance, that before alarm on, my clock radio was on in any other mode. So, for instance, in off mode. Okay. When the user puts the alarm on, okay, there is a change in state, so the clock radio goes into the auto state, but still silent. And what's interesting is that when the alarm time, when the current time becomes equal to the alarm time, then it rings. Okay, so I can enrich my scenario diagrams. It's UML2 compliant. Okay, so not much time left, but we can try to begin logical architecture. We have not many functions. So let's close a few tabs for me. Oh, maybe I close this. Okay, I have only two functions, display time, where display is display and manage, trigger, okay, it will be enough. Okay, so now suppose me or somebody else wants to begin the architecture of the clock radio. In fact, the system analysis level describes what is requested. Okay, it's requested that the clock radio is able to display the current time, is able to trigger an alarm when it has been put on, and so on and so on. Okay, so now, at logical architecture level, I will try to imagine, to invent internal components inside the system. Maybe I will have to break down functions, because maybe the display time here is in fact really the display of the time, but also the manage of the ongoing time. Maybe the trigger alarm is not only trigger, but also managing the alarm commands that come from the user. So maybe I have at least a logical component dealing with user interface and one or two internal logical components dealing with how the time is managed and so on. So now we are really thinking about how the system will do it. So first we have a look at what we've done at system level. So at system level, we have already done several diagrams and matrices. Of course, we can double-click on any diagram and so on and so on. And I can show you the semantic browser once again. Okay. Display time. So now on one function, if I select one function in my SAB, okay, for instance, display time, now there are a lot of different things to say. It's allocated to a structural element. It has an incoming functional exchange from another function. Okay, it's active in 3 modes. It has 2 outgoing functional exchanges. It realizes an operational activity at operational level. And in fact, it's displayed in 2 diagrams and 2 matrices. Of course, when the model evolves and gets bigger, the semantic browser is more and more useful. Okay, let's begin logical architecture. So once again, at this level, it's completely empty. So what can I do? I have to, I will not have time to do this, but maybe. Typically, if I have a function like manage alarm in our example, and I want to say that a part of it will be done by one logical component and a part of it will be done by another logical component, I have to break down the function at logical level. I can keep it as it is at system analysis level, it's nice, but at logical architecture level, I have to break it down at least into 2 functions. One will be allocated to the user interface manager logical component, and one will be allocated to the other logical component. Okay, a function in Arcadia can be allocated only once. Once again, it is an important and very useful and efficient methodological guideline. So we could do it we can begin it. The functions that I have to realize in my logical architecture, of course, in the beginning are the same as the ones that were described at system analysis level. So I wouldn't like to be obliged to write again the same kind of function and functional exchanges. So here, there is a very nice feature in the tool. Okay, we have system functions, but at logical architecture, of course, we don't have yet any logical functions, okay? We could ask the tool, initialize for me the logical architecture level with these names, and I will break down the functions that will need to be broken down. But maybe there are some, specifically those which are in the actors, that I don't need to break down. So I just want to get them again at this level. So there is a little tool here that just creates one logical function for each system function and creates also functional exchanges at logical level. So, okay, let's do it. We can choose a subset if we want. We just have to uncheck things. So here it works at model level. It doesn't create any diagram. In fact, it has created logical functions, logical functional exchanges with the same name. This logical function realizes the system function. It created also the realization traceability link. Okay? To be sure, I can ask the tool to display functional breakdown. Remember, breakdown is always up to date. It's not empty if there are some elements. So here the functional breakdown should be, very simple, 5 functions. some are outside in the actor, some are inside. By the way, I know that set current time and wake up are in the user. They are all the same. In fact, I can ask the tool, at logical level, I need also to have logical actors. So maybe you could do it for me. The user system actor, just create a logical actor called user and allocate the same functions. Okay, actor, function, allocation, it's done. And now if I go back to my LFBD breakdown, you can see that 3 functions are blue now because they are inside the actor, in fact. Okay, so in fact, I will work on the system function, and for instance, I will have to create at this level, okay, there is something to manage time. It's an internal function now, okay? And there is something really, okay, the display is badly named at system level. Show current time. Okay, so the idea is that now I have 2 sub-functions. And now, in fact, and the same for alarm. And now I would like to create a logical architecture diagram showing sub-functions allocated to different logical components. Yeah, I try. So I just have to create a LAB, logical architecture diagram, same kind as the system architecture diagram, but there will be components inside. Okay. By the way, I could put this like this. I don't want to put the actor and resize it, so there is a little trick here. There is a little accelerator. I can choose another diagram of the same type, but at a higher level, and the tool will insert the realizing elements at this level automatically and display roughly the same. Okay, nearly good. So now what I need to do is create internal logical component thing at this level. So I could have a user interface manager. I could have a time manager. And I would need a time manager because it's getting short. And an alarm manager, for instance. Okay, so at this level, this is new. And now I have to allocate the system functions, well, the equivalent of the system functions at the logical level. I have to allocate this function to the components. To do this, there is a manage function allocation tool. So in the user interface, yeah, it's bad. Okay, nothing. In the time manager, manage time. Yeah, user interface, show current time. Okay. Let's imagine. We are missing some functions, of course. Okay, let's put the show current time inside. Okay, and let's put roughly the trigger alarm inside. Once again, when you allocate a function, it disappears from the allocation wizard. When you have nothing to allocate, when the left side is empty, it means you have allocated all the functions of your model. So here you notice that a lot of things are appearing automatically, but here they are not appearing. Yes, because in fact, the data flow was on the display time function, and now I created sub-functions. So I will do it, yeah, 5 minutes. I will keep something at the end. So I need to break down also the functional data flow. So to do it, I can just refine the function. I will create a functional data flow block diagram, and I will insert only the functions that I need, display time and the 2 sub-functions, okay? And the functions that are linked that were linked to display time, so get time and trigger alarm, for instance. So trigger alarm is a function. If I put trigger alarm now, automatically the flows are good, but in fact, a function that is broken down is not really a function any longer. It's more a group. So alarm detection, goes from managed time. So here I change the model, okay? And there is an actor functions get time, well, maybe set current time also, by the way. Okay, so current time is going where? Is going to set current time is going to manage time, for instance. And set current time. No, it's from this one. Bad choice. Okay, show current time. It's an output. And set current time is going to manage time. Okay. So the idea is that the functional data flow that was at the display time level, now I've chosen to put it at a lower level, and of course I should have something probably like this to tell me which is the real current time that will be displayed to the user. Okay. Actual time. The good thing is that when I work on this little data flow diagram separately, in fact, if you look now at the LAB, all the data flows will automatically appear because the subfunctions were on the diagram. Okay? It's automatically updated. Well, of course, I would have to spend a few minutes making it nice and so on. Okay, nearly finished. Okay, too ambitious. Okay. Functional chains, I will not have time to speak about functional chains. You can describe so-called functional chains at any level, in fact, and then you can realize them, you can define them at system level. Functional chains are interesting for testing purposes and for latency requirements, typically, instead of individual function. And then a functional chain at system level will be realized by functional chains at logical and physical architecture levels, implying components. Okay.
Pascal,
Yeah.
you are until a quarter two, actually. So you have
Yeah.
still
Yeah.
5 minutes.
Yeah. I know. So it's good. Thank you. Okay, but functional chain takes too long. I want to show you something else. Well, I can create one. Okay. So we can create one at system level. So if you go back to your SAB, imagine that I have alarm on, and, well, here it's very simple. I have alarm on and alarm going out. So with the shift key, you do a multiple selection. You hold the shift key and you create, but it was not good. Yes, because there is a loop. Okay. So I create a functional chain with only one for the moment. Okay. So this is the alarm functional chain. I can create as many functional chains as I want. Okay. And then this functional chain, I can modify it in a specific diagram called functional chain description. And I want to say that trigger alarm goes back to wake up, but in fact here you have to put twice wake up and put the alarm like this. Okay, specificity. And if we go back to the SAB, functional chain is updated. Of course, it could have gone to alarm detection and so on. So probably alarm detection is good also. So here it's too simple, but the idea is that you can create a functional chain, and then this functional chain, by the way, where is it in my model? if I close the model and I click on F8, yeah, it selects, so functional chain is a model element also. Okay. And the functional chain, I can ask the tool, transition it to the logical level. Even if I do it afterwards, I'm able, in fact, to transition more than once. Transition little tools are iterative and incremental. That's also very powerful. It's not just one shot. So I can individually transition this functional chain. Okay. And it creates now a functional chain at logical level. Probably at logical level, as I have decomposed the functions, it will be invalid yet. Okay, but it's a good start. So if I ask the tool, show me the functional chain as it is, show me the functional chain on this diagram. It's valid. It was so simple. Yes, I didn't decompose trigger alarm. So it's even valid, in fact. If it had something to do with these functions, it would have been invalid. Okay. So functional chains are linked together by realization links, like functions or functional exchanges or anything. And what you do is that you specify, for instance, latency at system level, and then with a specific performance viewpoint, which is an additional tool to Capella, you can put latency values to your physical components at physical architecture, physical functions, physical flows, and so on. And the tool can compute the latency of a functional chain, and it will tell you whether it is less or more than what was specified at system level. So typically, a performance viewpoint that will be available soon in Capella will do this. Calculate latency for functional chain at physical level and compare them to requested values at system level that you have put in your analysis. Okay. Okay. And another thing that is very interesting, remember we did a scenario at system level, but now I've invented logical components inside my system, and the functions and the functional exchanges have been allocated to these logical components. So it would be nice if the tool could initialize from this scenario and from this, okay, a simplified view. Let's put a simplified view of this. Collapse function ports, hide functional exchanges, and remove the functional chain. Okay, so I see just the allocation of function inside my logical component. So I would like, instead of a clock radio vertical line, I would like to have the exact subset of the necessary logical components for this scenario. Okay. And the tool knows everything, in fact, because it knows the scenario level, the scenario at system level, and it knows the allocation of the functions and the functional flows at logical architecture level. So let's ask the tool to do the job. So in fact, I just have to go to the system level scenario, this one, containing the user and the system and the 3 messages and so on. Okay, to prove that it's not cheated at logical architecture, there is nothing, there is no scenario. Scenarios are always under capabilities in Melody, in Capella. So right-click, transition, system exchange scenario to initialization. That sounds good. So transition doesn't do any diagrams. They always work at model level. So now I have at logical level, I have the alarm manager and the user interface. So I have 2 components out of 3, by the way. Okay, I don't have the time management inside. So I just need to ask the tool, okay, create a diagram from this. Okay, there is a little bug in this 0.8.1. There are some green rectangles, stakeholder for functions, but not properly defined. So should be, there should be a 0.8.2 very soon, by the way. I don't know if you have seen on the Capella level and the allocations that I've done and so on. The tool could only do this. Okay. Well, which is not bad. So you have the 3 messages. So maybe what we need what we need to add now would be internal messages between the components, for instance. This one, well, the one that I've, where was it? The one that I put between in the logical data flow blank. Yeah. This message, for instance, the tool could not guess if it's in the scenario or not. So the actual time, I can put it from alarm manager. So probably I need the time manager component and so on. So it's an initialization of the scenario from the system level scenario. And I have just to add internal messages and things like that. But I'm sure that they are consistent. And by the way, the scenarios are linked by realization links, once again. All these realization links are visible in the semantic browser. And of course, if you make requests on the model, they are navigable. Okay. At physical architecture level, what we can create is nearly the same, except that we have 2 natures of physical components. We have so-called behavior components, which are blue, and to which you can allocate functions, like in logical architecture and system analysis. And you have yellow physical components called node components or implementation components that provide resources. The yellow components, they provide resources to the blue components. For software-intensive systems, typically, blue physical components are software components and yellow are hardware components. And of course, you can deploy several software components on the same hardware. You can allocate several functions to the same behavior components and so on. So this distinction is useful because you probably have different properties for the hardware and software components. You have, so for performance, safety, price, mass, viewpoints, usually software doesn't weigh too much compared to hardware. Price, maybe more. Okay, so the idea is that at physical level, typically, it's where you will use these so-called viewpoints. So it's been announced in Capella, but okay, it's not yet available. It will be soon available, should be beginning of this year. So it's nearly the end of the beginning of the year now. So there should be very soon a mass viewpoint, a cost viewpoint. So very simple, you can put mass and cost values to physical components. The tool automatically computes sums for container components and compares to values that you have at system level, for instance, or max values that you put. and put little green and red gauges like this. There will be also a latency viewpoint dealing with functional chains, but it's also simple sums. Yes? They are available? Ah, when was it? 2 weeks ago. Oh, okay. Fine. Thanks. So these are so-called demonstration viewpoints. Of course, a viewpoint, a safety viewpoint, for instance, can be much more complex with very complex algorithm. Okay, mass and cost, just additions, not very, and comparisons. But latency is the same, in fact. Safety viewpoint can deal with propagation of degraded modes, component exchanges, and so on and so on. So it can be quite complex, in fact. And the idea is that you have the tool to define your own viewpoints, so to extend the Arcadia meta model, in fact, to define new properties and to add this viewpoint. I think that in the next workshop with Sirius, you should have some ideas on it. Okay, so there is an API for viewpoint development that is already available inside the Capella project under Polarsys. Okay, so 5 minutes conclusion. Okay, it was quite difficult to do the demo with all the functions that I wanted to show, but okay. So what's very important is that usually when we present model-based system engineering, we say that there are 3 pillars: language, method, and tool. Okay, a lot of people believe that they do model-based system engineering as soon as they choose a modeling tool. Many managers think that choosing a modeling tool is enough and training the people to the tool is enough. Well, unfortunately, it's not the case, okay? You really need to understand what you want to express, so which is the best language to express what you want. Then, with this language, you need a method. And as you have seen on Capella, for instance, even with Capella, where you have well-defined abstraction levels, you still have nearly 10 different types of diagrams available at each level. So, of course, you have to choose. You have to choose the necessary subset, because else you will spend all your project time to model, which is probably not the main objective. And the tool, ideally, must know the language, of course. All the SysML tools, they know SysML. Well, some better than others, but okay. And the tool, ideally, must know your method. So in UML and SysML, there is no method. So you have to build additional tooling upon commercial tools, for instance, to do this. In Capella, you have already built-in facilities. You have the methodological guidance. I didn't show that you have some validation things. Okay, I've not done physical architecture, so I have a lot of warnings telling me, ooh, all these things are not realized at physical level. Yes, okay, I know for the moment, but thank you to tell me. Okay, so the tool automatically checks that your levels are consistent and things like that. So if the tool knows not only the language but also the method, it's even better, of course. So the idea is that Arcadia covers both language and method, and Capella, the tool, knows both. So that's a big advantage. Of course, links between all these different diagrams, like in UML and SysML. No, I didn't show you. There is a data modeling part in Capella. You can have UML class diagrams. It's as powerful as UML class diagrams inside Capella to define data model. Okay, so methodological guidance, semantic color map, semantic browser. Oh, I didn't show a last one. 1 minute. If I select this and I say delete from model, which is of course different from delete from diagram, you guess. Delete from model tells me, take care, if you delete this, you will delete functional ports, you will delete incoming and outgoing functional exchanges, you will delete the realization links, you will delete allocations and so on. Are you sure? Okay, and if you say yes, it deletes everything. Yeah, it should. And undo works. Same time. Yeah. Undo has created everything again. Okay. So there are some interesting features in this tool. If you want to know more, everything is on the Capella website, which is quite already consistent and complete. Okay, and of course you can follow my blog, and if you want to know more, 4 days is a good duration, better than 1.5 hours. Okay, thank you. I will be there for questions during the day, so don't hesitate.
workshop. My name is Frédéric Madiot. I'm working for OBEO, and I will present this workshop. There are six colleagues of OBEO who will help you during this workshop. So Etienne, Mélanie, Yvan, Cédric, and Samuel will come, and Arthur. Okay, so if you attended this workshop last year, the objective was to create a simple modeling tool with Sirius, a very basic modeling tool to let you discover the basic principles of Sirius. This year, we want to make you discover advanced features such as layers, filters, conditional styles, tables, validation rules, quick fix, etc. So the idea is to start from this very simple modeling tool. This tool is the one you can get if you make the tutorial which is available on the Sirius website. So it's a very basic modeling tool, and what we will do today, step by step, is to extend this modeling tool to add new features. So all the about this workshop to follow the different steps are explained on the tutorial.html. It's a file that you have already downloaded if you received my email. If you missed this email, you can get the .org/pub icon and 15. So before to start, you have to prepare your environment. All the instructions before the HTML file. You have to download OBEO Designer Community. It's a package which contains and Git. So with the material, you can find also a Git repository which contains the starting step, the initial state, and all the intermediate steps. And of course, the solution, what you should get at the end of the workshop. Okay? At any time, with this Git repository, you will be able to go to a step during a given step during the tutorial. So if you are too late during the tutorial, you can go further and go directly to a given step. Of course, if you your own modeling tool, if you came with your own modeling tool, you can also follow the tutorial and adapt the different the instructions to your own case. Okay? So the result of the workshop is a more complete modeling tool. If you see the first one, this is the start, the one you get if you follow the Getting Started tutorial. It's a modeling tool which allows you to represent members of a family, the men, the women, and the parental relationships, father in blue, mother in red. And you have also just one tool to create a man. Okay? So what we will do today is to complete this modeling tool and to get a more advanced tool with more creation tools. Of course, now we have created a tool to, we added a tool to create women. So we can create women. You can create directly from the diagram, you can create parental relationships. Okay. This is the result you will get at the end. Father, mother, take up. Okay. So you will add tools to create relationship. You will also add tools to create some edges. For example, if you want to change the end of you will be able to go to another man or to man by selecting the end of the edge. You will be able also to delete a relationship directly from the diagram, okay, by enter on the sub button. You will also be able to direct edit the label of an element, and this modification will directly modify the name of the person. Okay, here. You can see that if I modify the name is modified on the person. We will also replace PNG images. The basic tutorial is based on PNG images. So this is the initial one. So when you resize an element, it's pixelized. So with the new one, you will replace with SVG file so that you can resize without losing quality of your image. You can also notice that we have added conditional styles so that the label of a person changes depending on the number of children. For example, here, you have no children, the label is in gray. Grandchildren, you have grandpa or grandma behind, and so on. We will also add some layers to display men or women, and some filters, for example, here, to hide the person without children. Okay? We'll also add some validation rules. Here, if I use the property view, I can change the father of Dave and set his son, which is forbidden, but you can do it by using the property view. So if I set Alan as a father of Dave, father Alain, okay. If I validate, now you will have on the two elements, okay, with dedicated messages. And this error can be corrected with a quick fix. So you can select quick fix and select this quick fix to unset one father relation. Okay? Okay, and finally, you will add also dedicated diagrams for persons. Here we have a diagram for the full family, which displays all the members of the family. You will create dedicated diagrams for persons. Okay? So for example, here, I can go to different persons and I have a dedicated diagram with the person, its children, its siblings, and the father and the mother as border node. Okay? And finally, you will create a table which displays all the members of the family with the father, the mother, the number of children, and the number of cousins. Here it's 0, but if, for example, I add children to Leah, you can see that Dave and Clara have a new cousin, and this woman 8, has 4 cousins. Okay? This will be calculated by a Java service that you will create. Okay? This is the end of the tutorial, the target. Is everybody ready to start the tutorial? Okay, you have the different material, OBO Designer, and the starting state for this tutorial is this basic designer, which is described here. Okay, and a basic sample which corresponds to this model. Okay, everybody is ready? Okay, so just before to start, just a few words about Sirius. Sirius is a technology to create rapidly some modeling tools. So the principles of Sirius is that you have a runtime which interprets a specification file which describes all the modeling tool. So the diagrams, the tables, the elements of each representation, the tools, all these elements are described in this configuration file and interpreted dynamically by Sirius to provide the modeling tool to the user. Okay, so just an example. You can, for example, for the family, create a container for the family, and Sirius will describe this container. So the specification file describes a container, and it is associated to the family concept. And for this container, you can, for example, create mappings for the concept of man in the family. And so each man, which is a member of the family, will be displayed with this style, which is associated to this element. There is also the same ID for woman, so you can associate an image to the woman, and you can also describe the relationship with edges on your diagram. Okay? So the resources that you will manipulate during this workshop. So you have the domain model, which is a meta model describing man, woman, family, father, mother, children, parents. You have a sample model with a family and some men and women, which are based on this domain model. And with Sirius, you will extend a basic tool. The first step is, the initial step describes a man, woman, father, mother, and a tool to create a man. And Sirius will interpret this tool to create graphical representations of your model. Okay? So this is an eCore model. This is a sample EMF file, which is provided. This one is provided here, okay? Example family on the basic family.sample, which is a sample project containing a sample model. The ODesign is a file which describes the modeling tool. You can find this file in the .design project, and this file is here. This file, you can open it, and you will find all the elements which describes the basic modeling tool. And the representations are created in this file, representations.ird, which is in the basic family sample. It is here. And this file contains all the representations of your model created with this modeling tool. Okay, so the meta model is here. You can find it also in your the first Eclipse, where you have installed the meta model. Okay, it is here. And the workshop will start from this model. Okay? And during the workshop, you will create what I have shown previously, edge creation tool, reconnect, delete, direct edit label, and so on. Okay? So let's start.
Anybody needs USB stick?
So the first step, as you have seen, I will just display. Okay, side by side, the description and the result. And you will see that the result, the diagram will evolve step by step during the completion of the modeling tool. So here you can see that I have only one tool to create instances. I have a create man tool. The first step is to duplicate this tool to create woman. So here I have the properties of this tool, and you just have to replace man by woman. Okay, select a new node. Okay. This tool will execute these instructions. It will create an instance of family man. You can replace it by woman. You can use automatic completion, control space, and you have all the available types of your meta model, of your basic family meta model. So I will replace man by woman. Okay, and finally, after the creation of this instance, we execute a set instruction to initialize the name of the new instance. So the name will be set with the result of this expression, which will calculate the number of women, not man, and concat this to the string woman. Okay? So for this tool, you change man by woman in the definition, in the create instance, and in the set name. If you save the description of your modeling tool, Sirius automatically interprets the modification, and you can see a new tool in your palette. Okay, let's test this tool. Now you can create a new woman. Woman 6, if I create another one, woman 7. Okay? Okay, so now we will add two other tools in the palette to be able to set the father and mother relationship directly from the diagram. So go back to the specification model, and you can add new element creation, an edge creation. Okay? This tool set father. It will be associated to the edge which displays the father relationship, father edge. Okay, and it will just you have to change the context to get to one of your elements. When the user will click on set father, he will have to click on two elements on the diagram, the son and the father. Okay, so the first element which will be clicked will be set to the source variable in this tool, and the second one will be in the target variable. So here, I just have to specify the context on which I will execute the next operations. I decide to go to the source. And on this source, it will be the son, the first one on which I will click. I will set his father relationship. This is a relation defined in my meta model. And I will set the second object on which the user has clicked. It is the target. It is in the target variable. Okay? So you have this set father. It is associated to the definition of this link, father edge. And the action is to go to the first element and to set the relationship father to the second element on which the user has clicked. Let's test it. So I saved my definition, and now you can see a new tool in the palette, set father. Let's test it. I click on woman 7. I can go to Albert, and the edge is created. And if you go back to the property views of woman 7, you can see that its father relationship has been set. Okay? So we'll copy and paste this tool to create the same tool to create mother relationship. So replace father by mother, change the edge, mother edge, and change the action. This is still correct, but I will change and replace father by mother. I save. Here you can see the new tool, set mother. We'll test this tool, and for example, set the father of Catel to woman 6, and it works. Okay, woman 6, mother. Now we will add a precondition to this tool to avoid the user to do some things like this. Okay? We don't want the user to be able to do this, or to do to create a mother, for example, this. We want to forbid this also. Okay? So this can be done with a precondition. We just delete this mother, okay. And woman 7, mother, woman 7, no woman. Okay. So let's go back to the definition of the edge, set father, and you see that you have a field, connection complete precondition, which will be evaluated when you are going to select a new element. Okay? So to determine if you can click on this element, there is a precondition which is evaluated. Here, it is, the connection is allowed, okay? But we can forbid this connection in some cases. We just have to define a condition. So the condition is defined by an expression, Axelo3 expression. So here, we have two specific variables since the click has not been performed on the second element. So we have pre-source and pre-target variables which are available and which are set with the elements on which we are going to click. This, for example, here, pre-target is set with woman 7. I have not clicked, so pre-source and pre-target are set before the end of the action. So I can use this variable and to add an expression, for example, pre-source different of pre-target. Okay. If I save, now if I, it was set father, if I go to a man, if I let my mouse over Dave, you can see that the link is forbidden. Okay? It is authorized here, but it's forbidden here. You have the specific sign. So let's complete this precondition to also forbid the link between a father and its son. So you can add and not pre-source dot children includes pre-target. So here it means the children must not contain the person that I want to set as a father. Okay, so let's save this new precondition, and if you test it, if you click on Dave, you cannot anymore click on Alan. Okay, you can click on Albert, but not on Dave and not on Alan. Okay? So you can copy this expression and paste it on the set mother relation. It is the same expression. You don't have to modify anything for this precondition. Okay, and let's test it. Let's test it. So Catel can be the mother of Catel, and woman 6 can be the mother of Catel. Okay? So now what we want to do is to enable the user to make the user able to change the end of a relationship. For example, I am creating my model and I have missed one relation and I want to say, no, it's an error. Woman 7 is not the mother of woman 6, it's Leah. And I would like to be able to change the end of my connection. So for this, you need to create in the section a new element edition, a reconnect edge tool. Okay? Reconnect phaser. You can slowly? Okay. Reconnect phaser. You can associate the reconnect phaser to the phaser edge. Okay? And here you have more variables. You have the element. Element is the first element on which is attached to the edge. For example, here it's CATL. And you have the source. Source is now the first element which was attached to the edge, and target will be the second one. So here, CATL is the element variable, woman6 is the source, and Leah is the target. Okay? Element, source, and target. So what we want to do when we reconnect a phaser relation, a Moser relation, I am on a phaser, so here, I want to say, okay, now if I click on this edge, if I do this, it means that the new phaser of Alain becomes Elias. Okay? So the first thing to do is to go to Alan. So create a change context object. And I go to the variable element. Okay? It means I'm going to Alain. And since I am on this element, I can create a new operation, a set operation. And here, I want to say the new phaser of Alain is Elias. So I will set the relation phaser to the second element on which I will click, which is the target variable. Okay? So the reconnect phaser, you have to specify which edge will be reconnected by selecting it with this button. And to specify what will be executed when the user will reconnect the edge, you will go to the source of the edge, which is in element, and set the phaser relation to the second element on which you will click. Let's save this object, this new tool. It's not a tool which will appear in the palette. It's normal. But now, if I select this edge, I can set a new phaser to Alan. Okay? So you can copy and paste, if it works, this tool to be able to reconnect also the Moser relationship. So you copy paste, you change phaser with Moser, and you just have to change here. No, you have to change also the mapping to associate the phaser edge to this reconnect tool. Okay? And the action is not to set the phaser, but to set the Moser relation. let's save this new tool. And if you test it, woman 6, oh, no. Okay, thank you. No, mother. In the mapping, okay. Thank you. Okay. It's okay for everybody? So we will now add another tool to allow the user to delete some elements. By default, you can delete nodes, persons, because the node is directly associated to an instance of the model. So for Sirius, it's easy to determine which element should be deleted. But with a relation, it's more complicated. Relations can be indirect. So you can put an expression which will determine the display of this kind of element, of edge. So it's not possible for Sirius to guess if I want to delete this relation or this graphical object, which semantic action should be done behind. So we have to specify it. So you can create a new element edition, which is a delete element. Delete phasor. You associate to this delete tool the phasor edge. And you have to specify the action. When the user will delete on the edge, what Sirius has to do on the model. Here it's simple. You have the element which relates to the selected element. In the case of edge, of an edge, the element refers to the source of the edge. So new operation, change context, we'll go to the element. And now you can add an operation, an unset operation, to unset the phasor. Okay, you don't have to specify which element will be removed because it's there is only one phasor. Okay, so now let's test it. If I suppress this edge, now the edge is deleted, but also if you go to the element, you can see that his phasor has been removed. Okay. So you can also copy and paste this delete tool to create a delete mother tool. And here, what we will do is to remove and set the mother relationship. Okay? So delete element. No, I have not specified the mapping here. Okay. So the delete element, it has a name. It specifies an element, a graphical element, which will be removed, and you specify which will be executed by Sirius on this remove. Save it, and we test it. Okay. The mother has been removed. Of course, you, on some cases, on your diagram, you can have much more complicated actions to specify. Okay. Another tool we will add is to allow the user to change the name of a diagram element. So now we will use a new element edition, a direct edit label tool. This tool will allow the user to change the name of a person. So, edit. Can name it edit name. We can associate this tool to any element in the model which has a name. So, man node and woman node. Okay. And this tool comes with, by default, one variable which will be set with the expression, so the string, which will be entered by the user. So the expression will be set in the 0 variable. So here I can create an expression, a set, and I will set the name with the content of the 0 variable. Okay. So edit name, you specify the elements which can be renamed, and you say, if I use this tool, on the selected element, I will change the property name with the value which has been entered by the user. Okay? You can save it and test woman 6. Yes. Okay, it works. Okay. Okay, we'll continue to complete this diagram element, the diagram, and we will improve the images. So here, behind men and women on the diagram, we have a style. Man node, woman node have a style which is specified by a workspace image which refers to a PNG file, PNG image. And this PNG image, if you resize it, it's pixelized. Okay? So we can improve this by replacing the PNG images by SVG images which are on the icons folder, man and woman SVG. So you just have to replace man 32 man SVG. Okay. I have to restart, to reopen my, some modifications can be rendered on live, but some other one need to restart your, reopen your diagram in order to take the modification into account. Okay, so Alain can be resized now with the SVG image. Okay, let's do it for woman. Woman.svg. Okay. Close the diagram, just reopen the diagram, and now you have an SVG file, image. Okay? So what we want to do is to make the label of each person to change depending on some properties of this person. What we will do is to change the name of the person depending on the number of its children. So you can add now. You go on the diagram. No, you go on the layer. You create a customization, a style customization. In this style customization, you will create a first customization, a first style customization. Change the person to gray if it has no children. Okay, so you just have to define the expression. Okay. Size equal 0. Just to know where are you in the tutorial? Everybody is in this step?
I mean, if I may say something, if you want us to do these things, you should do one step and then give us some time to perform the steps. Otherwise, either we follow you or
You can go to, you can use Git to go first.
we need some time.
Okay.
For me, it's okay. I'm just following.
Okay, it's not enough time to do by yourself. Okay, or you can follow the. Okay. No, I can give you if you want to. If some of you want to go to this step directly, or I follow by showing, and you. Okay, so I keep going. So on this customization, this customization be applied each time the element met this condition. Okay, and now I can create some customization of specific graphical elements. For example, to change, I will select a property customization by selection to select the right color, which will be applied the graphical element which represents the man, so it's a workspace image. And I will change the color of the label. There are some properties that you can change. If you enter control space on the property name, you can see what can be changed. Here I want to change the label color, and then I can select the color I want to set when this condition is met. Okay? If I go back to the diagram, you can see that all the persons without children, their label is gray. Brian, not the woman, because I have not associated the woman to this element, so I can add woman.svg to get also this style customization for the woman without children. Okay?
Well, in case you haven't seen, there is a tutorial.html file in the project. I don't know if you can open it. So if you kind of lost in the steps, or if you want to
see everything that Frederick is doing, and you have all the steps, and especially you have the grid go directly to this step. It's easier to get back on track or to just see all the operations in Russia.
Okay, and all these instructions can be available, so you can see what I'm performing, and you can do it later if you want, if it's to speed. So this is the first customization. We will add another one to change the label size of persons with more than one children. So you can create a new customization with a new condition. And a new property to change, and this one is with an expression. So I want to change these images, and I want to change the label expression. And I want to set, not the label expression, label size. Label 12, for example. Okay. So each time a person has more than one children, its label size will be set to 12. Okay. Let's save the expression. And now you can see Elias, Isa, Paul with a bigger name. Okay. And finally, we will add a third customization to change the label of the person who have grandchildren. Children, size, okay, and we will set a new property customization by expression applied on the same object. Okay. And the property name now is the label expression. And I will prefix their name with grandpa or grandma. So here, if I want to prefix by grandma, I must remove the man. Only the woman, okay. Grandpa plus name. No, it's mother, donc grandma. Okay, grandma Isa is automatically changed. And grandma Ines, woman 7. And you can, with the same expression, same condition, you can change several features. So here, I will change not the woman, but the man, with another expression, grandpa. Okay, and now I have grandpa Elias and grandpa Paul. Okay? So this is done with these style customizations with 3 different conditions changing different graphical features. The label, the size, the color of the label, the size of the label, or the content of the label. Okay? Now, what we will do on this diagram is to add a layer or some layers. So a layer allows you to place some graphical elements on a dedicated layer which can be activated or deactivated by the user. So here I will create two layers, one to display the men and another one to display the woman. So on the diagram, you can create an additional layer, name men. Okay, you can select active by default. It means that when the diagram will open, the layer will be activated. And on this layer, you can drag and drop the elements related man and father edge. You can drag and drop to this layer. No, up here. And to get also the tool, you have to create a new tool section in order to drag and drop the create man tool, set father, reconnect father, delete father. All these tools are moved to this layer. Now if you save, see that you have a new layer. Hoopla. I will recreate my diagram. Okay. Ah oui, I just missed something. In the ODesign, the SVG, the image, the SVG by default are larger. So that's why when I create a new diagram, the images are very large. So you have to change on the style here. You can, in the advanced feature, the tab, set the size to 4. It means it corresponds to the same size than the previous image. Okay, and the same thing on the woman edge, advance 4. Okay, so now we recreate a diagram. Okay, and now I have this layer which is activated by default. Deactivate, and then all the men are removed temporarily from the diagram, and I can replace it. So you can do the same with women and create a woman layer. Oh no, see, that's not on the same right property. Woman, active by default, on the edge. Okay, and a section. And on this section, in this section, drop these 4 tools. Okay? Okay. Now I have these 2 layers, and it allows me to simplify the diagram to hide some elements, some kinds of elements. Okay? Now we will add a filter. What we want to do now is to be able to hide some elements, but not depending on the type of an element, but depending on the condition on some elements. So on the diagram, you can create a filter, composite filter, we will hide the children as a person, for example, without children. Children filter. You can define a mapping filter, and you will associate this filter to the elements you want to hide depending on a condition, man and woman node. And you just have to indicate the condition the elements must meet to remain visible on the diagram. Here, the condition is children size prior to upper than 0. Okay? So you have this filter with this condition associated to man and woman and this condition. If you go back to the diagram, you can now see that you have this filter here available for the user, and if he selects this filter, all the persons without children are hidden from the diagram. You can deactivate this filter. Okay? Now we will, you have seen previously with the final modeling tool that up here, that we can use the property view to create illegal relationship. For example, here I can create. I can say that the father of Elias is Dave, or we'll do it on Alain and Dave. Dave, I can set his father to Alain, his son. Okay? I want to detect this problem on my model. So for this, we can validation. Family validation, for example, and create some rules which can be evaluated on my diagram. So on a validation rule, you just have to define the level of the problem which you want to detect. Is it an information, warning, or an error? On which class of the meta model this rule will be evaluated. Here, we want to evaluate this on the persons. If the problem occurs, which element will be detected, will be displayed. Not on, let's say on man. And here, for example, we want to say if the problem is detected, children of plus name should not include his children. His father. Okay, this is the expression which will be displayed to the user when the problem is detected. And you just have to create an audit which will define the rule which will be evaluated. So here the rule is not children includes father. Okay? This is the condition to meet. Now you can go back to the diagram, and if you validate the diagram, you can see that this problem has been detected, of course, on both Dave and Alan, because they have both their father among their children. Okay? And the problems are displayed here. There are some, okay. And you have also here the problem. Okay? Now, what to do is to provide to the user a quick fix to fix this problem. So to the same problem, to the same validation rule, I can also add a fix. And the solution I will propose to the user is to unset one of the two father relations. And the operation I will do is to new operation to unset the relation father. Okay? So on the detected problem on a person, if I execute this fix, the father relation will be unset. Okay, so let's test it. So now I can select the problem here and select a quick fix. So this quick fix is this one. Okay. And if I execute this quick fix, the father relation from Alain has been removed. Okay. Is it okay? Okay, now we will create a new kind of relation, of diagram, to be able to zoom on a given person from the model. So let's create a new representation, diagram description, and this diagram will represent all the relationship from a person. Okay, this is a new diagram. Now, this diagram is not associated directly to the family, but we want to associate this diagram to a person, to be able to create this diagram on each person of my model. So the domain class of this new diagram is not family, but person. Okay? You can save it and create, if you go to a person, you can create a new diagram. But of course, it will be blank because I didn't specify any graphical element still on this diagram. But, okay, so I will close this one. This is my new diagram. And now we will fill this specification to get graphical element to display here. So what we want to display, default layer, we want to display each, the current person and his children in a list in this container. So I create a container, person container. This container will display instances of basic family person, and the sub-elements will be displayed in a list. And finally, I just have to define a style, a graphical style, and I will use a gradient with the color light green. Okay. Hop là. I have to specify, of course, an expression to say which element of the model I will display on the diagram. Here, I want to display the current element which hold the diagram. Okay. This diagram has been created on Paul, so I just want to see Paul on this diagram. That's why the expression is self. Okay, self is a current object on which the diagram belongs. Okay, we can change, improve the label. I want to set it to bold with 12 as the size. Okay? In this container, now I want to display the children. So let's add new diagram elements, subnodes, for the children. Children node. The children are also some persons. And the elements I want to display are the children. So for the current person, the children can be retrieved with this expression. And I have to specify a style in order to specify the label, the label style. Okay. So if I save, you have the container, person container, which displays the person, the current person, and its sub-elements as a list. And under this container, we have specified the children linked to the current person with the relation children and this style. Now, we want to display the siblings. So I will also use a container on the main layer. It will display the current person, but without the name, just the label siblings. So the element behind this new container is also the person. It is also the current person, so var self, and the result is displayed in a list. The style is also a gradient. I will 10, bold, and I will not display the name, but just the string siblings. Okay, and I want this to be displayed in yellow, light yellow. Okay, so we'll go to Elias, who has children and siblings. Okay, go to this person. I didn't specify the siblings, it's normal. So now I want to display the siblings. So I add a subnode, sibling node, The siblings are also persons. And the siblings are parents, children, and without me, so excluding self. So all the children of my parents except me are my siblings. And I have to add a style. Okay, with the label, it's correct. If I save, I can see the sibling of Leah, of Elias, who is Leah. Okay? I think I go back to Paul. No, Paul has no siblings. Who has siblings? Brian, for example. If I go to Brian, okay. So now we'll add a relation between this, a graphical relation. So you can also create an edge to link these two containers. Relation-based edge. Sibling edge. This edge will go from the person container to the sibling sibling node. It should be sibling container, but it is this container. Okay, and the expression to find the other object. This graphical object represents Brian, so I can use this expression also. And I can change, so if I save, I have this relation. I can select the graphical ends of this edge, and for example, decorators, I can select this one for the source and the same for the target. Okay? And finally, what I want to display on this diagram are the parents, so the father and the mother. So I go back to person container, and now I can add border nodes. Okay? So a border node will display the father and the mother. It will display the parent. There are person and the expression is just parents. Okay? I just have to specify a style. We'll use a square. I will display the label, the name of each parent inside the square, inside the node. And the color of the label will be white. Okay? If I save, I can see that Brian has Elias as a father. Okay? If I go to Elias, okay, Elias, you can see that he has a father and a mother. Paul and Isa. And these elements are border nodes, so they are attached to this element. If I move this element, these elements follow the container. Okay? Now, what we want to do is to be able to navigate easily from one diagram to another. So I am on this diagram. I would like to be able to go to the diagram of Paul and or go back from this, start from this element and go directly to the relationship diagram. And this, I want to be able to do this kind of navigation using a double click. Okay? So you can add, you go back to person diagram, to the section on the main layer, and you can add a new tool, navigation, element edition, double click. OK? Donc, personne, double click. I associate this double click to any element from which I want to be able to open the relationship diagram. So it means the children node, the man node, the sibling node, and the woman node, and the parent node. I don't select person container and sibling container because it makes no sense to go from the same diagram. Okay? And the action when I will double click on one of these elements to navigate, so I can create a navigation to this diagram. Okay? So it means that each time the user will double click on one of these elements, independently of the diagram, Sirius will open the relationship diagram corresponding to this person. And if this diagram does not exist, we can force Sirius to create the diagram. Okay, so now, if I go to Elias, I have to close the diagram and reopen to take the modification. Okay, new person diagram. Okay, now if I double click on Elias, it opens its relationship diagram. If I double click on Paul here, I go to Paul. And if I double click on Leah, Leah has not yet this diagram created. We can see here that she has no diagram. If I double click on Leah, we can create a diagram for Leah. Okay? Okay. Now we will finish the workshop with a new kind of representation, a table. So we want to list all the members of the family with their parents and the number of children and siblings. So you go back to the description of the modeling tool. You go to the viewpoint, create a new representation, and you select an edition table description. Persons table. It will represent a family with all its members. And in this table, we will display lines for each member of the family. Okay, so this table is composed of lines, and each line will display a person line. So I have to specify the type of the person, and the expression to retrieve the persons from the family is feature members. Okay, and I just have to change to specify the label of the first of the header, and I want to display the name of each person. Okay, so I have a table to display a family, and in this table I have some lines. Each line represents a member of a family. It is a person, and the label to display this person is the name of the person. So if I save, it is saved. If I go to the family instance in my Model Explorer, I can find a new representation, the table. If I create this table, I have my table with all the persons of the family. Okay. Yes. Now I want to add some columns to display the father. So in the table, I can add a new table element, which is a feature column. This column will describe, the first column will describe the father call. So I just have to indicate the feature which will be displayed, father, and the label. So the header will be father, and the label expression, I have to test if there is a father. So I have an expression to enter. So if father is OCL, completion doesn't work. OCL is undefined. Then I display an empty string. Else I display father.name. Okay? Okay, and I have my father column. I can do the same for mother. Mother table. If mother also is undefined, then else mother name. And the name of my column is not father column, but mother column. And I get the feature mother. Okay? I have the father and the mother. Now, I will add a third column to display the number of children. Children call will display the children and the label. The header will be children, and the expression will be children. Children size. Okay, I can verify on my diagram and see that, for example, Elias has 3 children, and his father is Paul, and his mother is Isa. Okay, and this table is dynamically updated if I modify something in my model. Of course, if I add a new children to Elias, okay, so I can see this new man 7, his father, and see that Elias has now 4 children. So the table and the diagram are synchronized. Okay. 15 minutes left. 15. So we can now add a new column to add the number of cousins. So the problem is that to compute this information is difficult with Axelo3 expression. So we'll create a service, a Java service, to implement complex operations. So here, in the project, you have a class, family services, with a method, getCousinsNumber. Okay, you just have to complete it, and copy-paste the result. So we'll take the content. Okay. It's not the right list. Person, a list of person, and import. Okay. So you have this method, which is completed. Okay, which computes the number of cousins of a person. Okay, so it's a simple Java class. There is no specific dependency to any other class. But to be able to use this Java class in my modeling tool, I need to declare this class. So you create a Java extension in your diagram, and you enter the qualified name of the Java class. Okay, so okay. And now I can use this service. I can use the methods of this class as services. Let's use it to create a new column, and a feature column to compute the number of cousins. Call feature name parents. We can use the exact feature is not really important here. What is important is the expression cousins, label expression. And you can call directly the service get cousins number. Okay. The problem here is that in this workspace, in this runtime, I cannot execute dynamically this method. I have to launch a third Eclipse to be able to execute this method and to test this new column. So you have to create a new launch configuration and to launch this new Eclipse with these arguments. It's the same principle than the first Eclipse you have launched from the meta model. Okay. So if I can run this new Eclipse. Okay, I have to import the sample model. Git. Take this one. Okay, just basic sample. Okay. I need to select the viewpoint to activate the different kind of representations. And now I can create a new table and see my cousins. Okay. There are no cousins in this model. So let's create some cousins. Okay, so for example, here, if children to Leah, Brian, Fiona, Clara, and Man 7 will get some cousins. Set mother. Okay, so now we have the new man has 4 cousins, and the other one have 1 cousin. Okay, this is the end of the tutorial. It was quite speed, but you have all the detailed instructions in the documents we have provided, so we can replay the whole workshop when you have time. And it will be published online on the Sirius website very soon with all the projects. So thank you for attending this workshop. Just to finish, if you want to know more about Sirius, there are 4 talks tomorrow. The first one about diagram animation in order to simulate, for example, a model. Sirius 3 to present the new and noteworthy features of the new version. And 2 use cases, 2 industrial use cases presented by Thales and by Safran in the afternoon. And in the end of the year, we will organize the first conference about Sirius in Paris. So it will be a one-day event, and you can propose some presentations about Sirius if you want. It will be a full day completely dedicated to Sirius. It will be a free event in Paris. And you can go to the siriuscon.org to get information and subscribe to stay tuned to this event. So thank you very much. And we are available if you need some additional information about Sirius. We are on the OBO booth. Thank you very much.
with the future tense. We've been repeatedly asked, don't you want to leave a better Earth for your grandchildren? And we've all collectively responded, fuck 'em. But incredibly, this latest damning scientific report may still face an uphill climb with some of us.
There's that Gallup poll that came out last month, which found 1 in 4 Americans is skeptical of all the effects of climate change and thinks this issue's been exaggerated.
Who gives a shit? That doesn't matter. You don't need people's opinions on a fact. You might as well have a poll asking which number is bigger, 15 or 5? Or do owls exist? Or are there hats? The debate on climate change should not be it exists, it's what we should do about it. There is a mountain of research on this topic. Global temperatures are rising, heat waves are becoming more common, sea surface temperatures are also rising, glaciers are melting, and of course no climate report is complete without the obligatory photo of a polar bear balancing on a piece of ice.
I love John Oliver. Okay, a couple of quick notes about myself. Monk.net, I'm on Twitter, Twitter/Tom Raftery, email, phone number, and I put all my slides up on SlideShare. So this talk will be up there later today or tomorrow, so you can go there and download it if you're interested. Also, most of my slides, not this one, but most of my slides have a link at the bottom to reference the data on the slide. So those are clickable links in the PDF that'll be on SlideShare, so you can go and check them out yourself. The talk structure here, it's in 2 parts. First is the bad news, you've had some of it already, and then we flip it around and we give you the IoT will help us do things better. So, the bad news. This is the Keeling curve. It's the longest running scientific experiment to date. It's been run consistently day in, day out since 1958. It was started by Charles Keeling. It's running out of the Scripps Institute on Mauna Loa in Hawaii. I hope I'm pronouncing that right. It's monitoring CO2 in the atmosphere. It's above the cloud inversion layer, so it's taking in the ocean winds coming in to Hawaii, and you can see the chart is going the wrong direction. Any direction that's not flat for CO2 in the atmosphere is the wrong direction. It goes up and down seasonally every year. That's why it's kind of zigzagged as you go to the different seasons, but essentially it's going up. 2013 was the first year it went above 400 parts per million. It did so for a couple of days. This year, in March, it stayed above 400 for the month of March, and it was the first time it stayed above 400 for an entire 400 today. It'll start to go down in the next couple of weeks, and it'll go below 400 again, but next year it'll go above 400 again earlier in the year, and it'll stay above it for longer. We're seeing, as a result of this, we're seeing warmest May on record. 2014 was the warmest year on record. 2015 is an El Nino year, so it'll be warmer again, more than likely. So 2015 will probably be, again, another record-setting year. As a result of which we're having heat waves. This one is and has killed 800 people so far, and that's that's a headline from this morning from the BBC. So right up to the minute. This is flooding in New Zealand. Again, this is this week. California's drought. Again, they're looking now at desalination, which is a massive energy footprint. Again, that's a headline from this week. And this is the result of the massive drought that they have in California. You're having 1,000 wildfires, over 1,000 wildfires right now happening between Southern California and Alaska, all the way up along the West Coast. To try and deal with that, at the UN Climate Conference in Copenhagen in 2009, 167 countries came to an accord to say we would try and limit global warming to 2 degrees centigrade. Now, centigrade is, if you convert that into CO2, it will take us 565 gigatons of CO2 to shift to 2 degrees centigrade more than the 1990 baseline. We've actually gone 1.2 degrees, no, we've gone 0.8 degrees already, so we have another 1.2 degrees to go. So to get to that 1.2 degrees more, we have to stick 565 gigatons of CO2 into the atmosphere. Now, to kind of try and make that a little more real for you, just try and consider what a ton of CO2 might look like. A gigaton is 1 billion tons. So we have to stick 565 billion tons of CO2 into the atmosphere. So that gives you some idea. Right now, we're currently putting about 50 gigatons per year into the atmosphere. And then natural processes like plant growth and oceans absorb 25 of it back. So we've got a little over 20 years left in our CO2 budget before we hit 2 degrees, if we continue on business as usual. The big problem, though, is this. The fossil fuel companies have proven reserves of 2,795 gigatons of CO2, and that figure comes from 2011, before a lot of the shale gas was discovered in the Marcellus Shale in the US and in England and a lot of other countries as well. So that 2,795 is a conservative figure. And when you compare it to the 565 gigatons of CO2, you can see we've got a problem, or the fossil fuel companies have got a problem. Because if they have 2,000 gigatons underground, it's their proven reserves. It's what their share price is based on. It's what their market capitalization is based on. It's what their borrowings are based on. They will lose 80% of their value if they don't get that out of the ground. They'll have stranded assets worth, if they leave it in the ground, it's a net loss to them of $21 trillion US. They're not too enthusiastic about that. This is why right now in Saudi Arabia, they're getting as much oil out of the ground as possible. The price is dropping, and they keep pumping it. They're not stopping, because they want that 565, they want as many of those gigatons to be Saudi gigatons as possible. And it's not just me saying this. This is a report from PricewaterhouseCoopers. They release this report every year. And again, the link is in the bottom there, downloadable. This is their low carbon economy report that they release every year, where we are currently. So they're projecting forward to 2100, saying that right now we are reducing our carbon output by about 1% a year. Whereas what we need to be doing is reducing it 6.2% a year to get to that 2 degrees C. So we need to start reducing it 6 times more than we are currently, year on year, between now and 2100. That's a huge ask. But there's some good news. Now that I've battered you over the head with nasty statistics about climate change, there's a little bit of good news, okay? So if we look at the breakdown of emissions, 38% of them come from electricity generation, and another 32% come from transportation. And we're currently moving the transportation fleet more towards electrification. So as we electrify more and more of the transportation fleet, we suddenly start to have a lever where we can control about 70% of the emissions if we start doing electricity generation more intelligently. This is the way this is the emissions from different forms of electricity generation right now. The bad ones, coal, gas, and biomass to an extent on the left. The better ones, PV, marine, hydro, wind, nuclear on the right. We want to be obviously heading more towards the right. Nuclear is a special case. It's a very low carbon emitter, but the difficulty with nuclear is it doesn't scale very well. And what I mean by that is it's very easy to build a 1 gigawatt solar plant. It's very hard and takes a long time to build a 1 gigawatt nuclear plant. So you can get solar up much faster than you can get nuclear. Similarly with wind. So a bit of background on electricity, and I'm bringing up telecoms here. This is Alexander Graham Bell, the inventor of the telephone, and this is him with his first telephone in 1876. Looks a bit different to what we have today. If you put one of these things in his hands, if he managed to figure out that it was a phone at all, he wouldn't know how in God's name to use it. On the other hand, this is Thomas Edison. He's credited with being the first person to architect an electricity grid. And if you put him in front of any of today's electricity grids, he'd have no problem whatsoever figuring it out, because they haven't changed a jot in the last 100 years. due to massive underinvestment. So, what we're doing is we're starting to make the electricity systems now a little better than they were. And right now, the electricity systems, they're buggy, they're read-only, you consume, you don't publish. They're top-down, they're closed systems, they're architected for the past. And what I mean by that is you've got large central generators pushing out energy. They're architected in such a way that the generation is controlled and the consumption is predictable. So the consumption patterns stay pretty much the same day in, day out. It's variable, but you know what's going to happen. What they're going to have to head to, though, is a system that's more like this. One where producers are all over the place, pushing energy into the grid, and that makes it a lot more difficult for them to control because you've got a system where you've gone from a controllable central generation to one where the generation, the supply side, is variable and not predictable. And the consumption is variable and predictable to a large extent. So that makes it a lot trickier to work with. The other thing about electricity grids is they're provisioned for hits. So this is an Alexa graph of traffic to the Australian Open website. And you can see that for 2 weeks in the year, the traffic is enormous. And then for the rest of the year, no one goes near it. So what the website owners of this domain, the Australian Open domain, what they do is obviously they use cloud. And they just turn up the dial when the traffic increases and turn it back down again. What they don't do is buy 200 servers and put the website across the 200 servers and leave the servers sitting there unused for 50 weeks of the year so that they can manage to hit those spikes every year. That's not the case with utilities. So utilities have to provision for hits. They have to build what are called peaker plants. And peaker plants are plants that are used 2, maybe 3 times a year. They cost hundreds of millions to build, and they sit there idle for most of the year until something like this happens. This is like half-time in the World Cup. And everyone gets up, goes to the fridge, opens it up, the compressor in the fridge comes on, they go to the bathroom, they flush the toilet, and you probably don't realize it, but when you flush the toilet, it has a huge energy footprint because it means that the big, typically Siemens water pumps that pumps water around cities have to ramp up and start pushing water, which is a very difficult thing to do. It's got a huge energy footprint. So at times like this, when suddenly everyone gets up, opens a fridge, flushes the toilet, boom, the generation has to go way, way up. Other times would be times like Christmas week in somewhere like the UK or Ireland. Christmas week, around 5, 6 o'clock, everyone comes home from work, puts on the oven, puts on the heat, turns on the Christmas lights, it's cold outside, so suddenly that goes up. I live now in the south of Spain, and the typical peaks for us would be times like August, middle of August, middle of the afternoon, 5, 6 o'clock in the afternoon. It is roasting. So everyone has their shutters down, windows closed, and aircon cranked up. So these are the times, those 2 weeks, 3 weeks in August, or those kind of couple of weeks around Christmas time, those are the times utilities use the peaker plants. The rest of the time, they're dead. They're not used at all. So it's massively wasteful. Electricity grids are dumb. And I have a little video to show you just to prove this point. This is...
It's impossible to know where the next storm's going to hit. When it does, it can wreak havoc on the power system.
There's a weather advisory in effect with high winds, heavy rains, and potential lightning.
I don't like thunder.
When outages occur, it's a race against time to get the power back. Many utilities rely on customers to notify them, and operators field many calls to narrow down the location of the fault.
Our power just went out. Could you tell me your address, please?
So when I said electricity grids are dumb, they're really dumb. That's absolutely typical. It's becoming a little less typical, but that's absolutely typical. The power goes out. They're analog networks. The power goes out. That the utility company hears about it is when the phones start ringing. And the first thing the operators do is, what's your address? So that now they know where the power is out. And then they send a truck roll. And the first truck roll is to go and try and find out why the power is out. So that then when they find the outage, they can ring back and say, okay, it's out because this transformer blew or this line came down or whatever. So then the utility company knows who to send with what equipment to actually fix it. It's incredibly dumb. But, like I say, it's getting better. Oh, the balance? Yeah, that was the other thing. Electricity grids obviously have to be completely balanced at all times. The supply has to exactly match the demand. And, I mean, you can't have too much electricity because there's nowhere for it to go, something will blow up. And too little electricity, you'll get a brownout or a blackout. So at all times, the supply has to exactly match the demand. And that's hugely challenging for utilities. Huge, particularly, as I say, when we're getting into an area or an era when we're getting more renewables on the system, and the renewables are uncontrollable and unpredictable often in terms of their output. So they're having a very tough time. And typically, this is their opinion of renewables. They see renewables as kind of the bogeyman because they're just so hard to work with. This is, I mentioned the supply, the demand. This is the Red Electrica de España. This is from their website, and again, there's a link there. You can call this up yourself. This is from the last few days. The gray ones along the bottom are days of the week. And one of them is highlighted, that's up there. That is the demand going from 6 a.m. on the left across to 11 p.m. at night. So that's absolutely typical demand. So you get a bit of a rise at 8 a.m., 9 a.m., 10, 11, peaking around 12 o'clock, dipping in the mid-afternoon and rising again around 7 o'clock in the evening. And you can see that if you look at the ones in gray underneath, it's very much the same pattern all the other days of the week, just slight differences in the height for the weekend. This, on the other hand, is the same day. So you can see the peaks don't match the demand. So that makes it, as I say, hugely, hugely challenging. In the Irish network, in 2010 this was, 9.5% of the electricity came from wind. It's getting a lot better now, but this was 2010. In that year, there was one day when over 1 gigawatt was generated by wind, and there was a couple of days when 0 came from wind. At the same time, the demand, the maximum demand, one of those Christmas week things, was about 5 gigawatts, and the minimum demand would be like a summer evening, about 2 o'clock in the morning, when nobody needs a lot of electricity, goes down to about 1.8 gigawatts. When you compare that, though, and you start to see a real challenge happening now, Ireland has an aim of going to 40% from renewables by 2020. If they go to 40% by 2020, again, you'll have your 0 on some day when it's not blowing, but you'll have your maximum of 6.3. On a nice windy afternoon, it'll go up to 6.3 if they get to 40%. That becomes an issue when that 2 o'clock in the morning on the summer morning, when the demand is only 3.6 minimum. Because suddenly you have 2.7 gigawatts of wind, and what do you do with it? You can't shut down the wind turbines, because if you do, you're cutting off the income of the wind farmers. And if you cut off the income of the wind farmers, then they won't get financing, and you'll never reach your 40%. So it's a big issue. Other renewables, solar. This is one of the most important graphs you'll see today. This is called the Swanson effect. The Swanson effect says that for every doubling of installed PV capacity, the price drops 20%. It's like Moore's law for solar. And it has held that way since 1977. So that's 1977 on the left. It's hard to see, I know. 1977 on the left, right up to 2013. Doubling of installed capacity, price drops 20%. And that leads to things like this. This graph is same kind of thing. In orange, you're seeing the price drop, and in blue, you're seeing the installed capacity. So solar is starting to boom, big time. China, I mentioned the nuclear power plants. They're trying to put up, I think, 3 or 4 gigawatts of nuclear in China at the moment, and they're having huge difficulties with it. All kinds of regulatory issues, the usual kind of things with nuclear. Whereas they're targeting 70 gigawatts of solar power by 2017, 2 years from now. It's unbelievable. And not just China, India have announced that they're going to go to 100 gigawatts from solar by 2022. And of course, if you get that 100 in India and 70 in China, you'll have more Swanson effect, and the price will continue to drop. In Dubai, a couple of weeks ago, no, it was actually last November, we had a broken record. They broke the record on the price of solar. There was a bid in for building a solar park in Dubai, 100 megawatt solar park, so not a big one. But the winning bid came in at 5.98 cents per kilowatt. It's unheard of. Previous records had been up around the 8 and 9 cent. The Aqua was the Saudi company that won the bid, also said that instead of 100, if they got a contract for 1,000 megawatts in the park, and the park is rated to take 1,000 megawatts, they said if they got the contract for 1,000 megawatts, then they would do it for 5.4. They got it for 200, and they're going to do it for 5.98. And the reason the Dubai people said that they didn't want to go for the 1,000 at 5.4 was they said, why would we? Swanson effect. We'd be tied into a 5.9 or 5.4 price for the next 25 years. Whereas now we can do 200 this year, 200 next year, price will keep going down, we'll keep getting it cheaper. If, and this is a bit of a thought experiment, I don't know the answer to this, nobody, but maybe one of you will figure it out. If the price continues to go down, and there's no reason to say it won't, and it goes to 5.4, and it goes to 4.4, and it goes to 3.4, we'll hit a situation where energy is ubiquitous. We'll have energy in abundance. Solar will be so cheap, it'll be built into roofs, in tiles. It'll be built into windows and skyscrapers. If it's 2-3 cents a kilowatt or less, why wouldn't you? So what do you do when you have an abundance of energy? Nobody knows, as I say. But I think it's a fascinating concept. And I don't see any reason why it won't happen. The price is going to continue to come down. So, who's going to create the Uber of energy? What are they going to do with it? Go for it. Seriously. Right now, the way we are, you can't, with the energy we have and the energy we're going to be creating, there aren't any really good options. You can't take energy and stick it in a box and put it on a shelf and wait for a rainy day. You can kind of, sort of. There are exotic storage solutions like pumped air, compressed air underground. There's also pumped hydro where you pump water. But these need specific geographies and massive amounts of money. The pumped air needs limestone caverns underground to pump the air into. You pump the air in there, put it under high pressure, and then run it back up through turbines when you want the energy. Similarly, with pumped hydro, you pump water up a hill and then let it come back down when you want the energy. To give you an example, there's a pumped hydro station in a place called Turlock Hill. It was built between 1967 and 71, and it was at a cost of then 20 million Irish pounds. So that would be billions in today's money. It stores 200 megawatt hours, so not a huge amount. And you can only build this in places where you have 2 lakes separated by about 400 meters in height. So specific geographies, it works really well when it works. There's a load of these in Spain as well. They work really well when they work, but they can only be built in certain places and they cost enormous amounts of money. Then you have things like this. This is a utility scale battery made by a company called Alevo. They're based out of Charlotte. I was in their plant last year and I took this photograph there. This is their new grid bank battery. It stores about 1 to 2 megawatts, and they sell it to utilities. And utilities are starting to buy them, and the price is coming down. Battery technology is taking off huge time. And then you've got residential type ones as well. So Tesla, for example, sell 2 batteries, 3, I guess, really. They sell their Powerwall battery, which comes in 2 versions, a 7 kilowatt and a 10 kilowatt. And they also sell their car, which has a 70 or 85 kilowatt battery, depending on which one you get. And this is fascinating, because these cars, these Tesla cars, and the batteries as well, are connected. So if you are Tesla, and I'm sure you thought of this, you are connected to however many thousand cars they've sold. Let's say he sells 100,000 Teslas or 100,000 batteries, and he's able to connect to all of them. Basically, he's got a virtual power plant. He can control them. He can, with the permission of the owner, obviously, if the owner signs up for the service, the owner of the battery or the car can start taking in energy when it's cheap and selling it out of the battery when it's expensive. And if you do that with 1,000, 100,000 of these, you've got a huge power plant. I guarantee you that in the next 5 years, he'll come up with a service like that for his customers. So this is where we get to the IoT part eventually. Sorry it took so long. The Internet of Things is baked into the electricity grid at the high level, at the high voltage level. Companies like GE, that last slide, this one, Iberdrola, and lots of the large manufacturers manufacture their devices to have what they call machine-to-machine technologies built in. So for example, CGI, who are, they're now CGI, they were the former Logica, they have a center of excellence in Portugal, in Lisbon, and I was there a couple of years ago, and this is a couple of, I'm sorry about the quality of these were taken with a phone of Windows screens, but this is their renewables management application. And basically what this does is it manages all of the wind turbines of Energia de Portugal, which is the Portuguese utility. It's about 2 gigawatts of wind turbines throughout the Iberian Peninsula. And each of those green dots represents a wind farm with 10 to 20 turbines in the farm. So you can double click on that window and you get into whichever wind farm that you've clicked on. You see the turbines in the farm, and you can see some of them there have got alerts on flags. Some of them are spinning fine. This is because these turbines are outputting hundreds of megabytes of data per minute, and it's getting sent back to this application that's being run by CGI. Typically, it would be run by the utility. And this is another view of the same kind of thing. The list on the left is the list of the wind farms, and the lines going out, green and blue and pink, those are the actual individual turbines. And you can double click in on an individual turbine, and it gives you a whole slew of data about that turbine. And CGI built it for Energia de Portugal because Energia de Portugal wanted to go back to the manufacturers of the turbines and beat them over the head with the SLAs and say, look, here's the performance you promised us, and this is what's actually coming out. But it means that these wind turbines are sending huge amounts of data back, and the same with solar panels, they all do as well. So they're all connected. In the medium voltage side of the house, so you go from high to medium to low, the medium voltage side of the house is starting to become digitized as well. And companies like Schneider Electric build, this is a smart city project that they're doing in Lyon. And you can see they've got residential connected up, not behind the smart meter, but from the smart meter forward to the substations and the transformers, and they're all talking. I was in the Schneider Electric headquarters in Massachusetts last year in September, and their CTO there was telling me that they now can put a system on a chip for less than $2. And because they can put a system on a chip for less than $2, he said, we're putting the we manufacture. Every single item we manufacture now has a system and a chip on it, which means they're all connected and they're all communicating. So from now on out, and Schneider makes, and Schneider is ABB well. It's just I happen to be talking to them, so ABB. And then you get to the low side, and that's where it becomes really interesting for us. Because we've got things like the Nest making their smoke detectors, making their cameras, their security cameras, and the thermostats. And I got a tweet the other day from a guy, I'm sorry, but he tweeted that for only $200, you can now let Google install a camera in your home. I thought it was really funny. But anyway, it's one way of looking at it. But no, more seriously, we're getting all these devices in our homes now that are connected and talking to each other as well. And then you get things like this SMAPI, which is the start. This is a little device you can put in your home. You connect it up to your fuse box, and you get then on your phone, you get all the information about your electricity consumption device by device. So it sees every device in your home, and it tells you how much each device is consuming. And you can see that while you're away from home, you can be out at work, whatever, and check what's happening at home, which has privacy implications too, obviously. But it starts to give you a huge amount of information about the devices in your house and how well they're performing or not. And then you can start to see maybe if I change the time that this works, or maybe I need to swap this out, or maybe there's a problem with the compressor in the fridge because it doesn't seem to be going off, or things like that. And then you've got things like SmartThings, and SmartThings, I don't know, has anyone heard of SmartThings? One or two? Yeah, so SmartThings make an application which you have on your phone, which allows you to control lots of different devices in your house. Now, they have to be smart devices, obviously, but again, the things like the Nest thermostat and those kind of things, the smoke detectors, the door locks, any of these kind of things that are now starting to be made smarter. So this application allows you to control those, from wherever. And the reason I'm talking about all these things is now we have everything, or we're starting to get everything connected. We've got the low voltage side of things, we've got the medium voltage side of things, and we've got the high-end, high voltage things all connected. Not connected to each other, but they're all connected to something using IoT technologies. So what we should start to do, and where we can really start to make a difference here, is we should start to have them talk to each other. And we should get them to adjust their behavior automatically. And this is starting to happen. What you may not be aware of is the price of electricity on the open market can change. This is a graph of 3 days pricing. The days are color-coded there. So 3 days pricing of electricity in Ireland. And you can see that there are peaks there that are an order of magnitude greater than the trough. So the pricing in any day varies enormously throughout the day. And we're never exposed to this. We pay a flat rate typically. Some of the better utilities now are exposing us to a little bit of that by putting time of use pricing, but not all. It depends on the market. Some of the utilities are better at this than others. But if we start to expose our devices to this and have them adjust their behavior accordingly, then we start to get some really interesting outcomes. We can start TiVoizing our electricity consumption. And why is that interesting? Well, there are lots of loads in our homes that are movable. There are lots that are not. I mean, you're not going to get up at 4 o'clock in the morning and turn on the oven to make your dinner because it's cheap. But your fridge or your freezer typically are well lagged. They're well insulated. As long as your food is fresh, you don't care when the compressor comes on. So if the compressor comes on at 3 or 4 in the morning and brings the freezer from it into minus 30, you don't care. It's well insulated as long as it doesn't drift too far up again. If it does, it just comes on for another couple of minutes. But you can have the fridge be more intelligent and consume electricity when it's cheaper and better. And by the way, I'm saying cheaper. You may not be aware because it's quite counterintuitive. But when electricity is cheaper, it's also greener. I know that you might have been told that gas and coal are cheaper than wind, and therefore you would suspect that electricity, when it's cheaper, is full of gas and coal, but it's not. It's quite the opposite. It's the opposite because on that open market where the price is fluctuating, the fossil fuel companies drop out of the market when the price goes too low. So as the price drops, they say, okay, we're dropping out, we'll see you. But the renewables stay in the market. They're what are called price takers. So as the price continues to fall, they say, okay, just give us the money. We don't have any startup or shutdown costs. We'll keep taking it. So they keep taking the price, and as the price drops, the percentage of renewables in the system goes up. So if you're actively selecting for cheaper electricity, you're typically selecting for greener electricity. So it's good to select for the cheaper, greener electricity. We're starting to get smart appliances now. This is a Whirlwind washer, and you can see it's got a smart grid delay built into it, the kind of thing I was talking about, where it listens for pricing signals from the grid. That's proprietary, I know, but it does. It listens for pricing from the grid. When is it best to come on? And for things like dishwashers, for clothes dryers, for clothes washers, if you put them on at 7 o'clock in the evening, as long as they're done by 7 o'clock the following morning, you don't care when it happens. The same with the charging of your car if you have an electric car. You start to time shift the electricity. You start to, A, match the demand to the supply, but also what you do is you start to, do you remember that 2.7 extra gigawatts of electricity we had in Ireland on that windy night when there was no demand? Suddenly, if all the cars and all the washing machines and all the fridge compressors start coming on at that time, you start to consume it. So as you move the demand to match the supply, you make a greener grid. You make it, you make it more stable, and the more stable you make it, the easier you make it for utilities to add more renewables to the system. And just this year, an organization called EPRI, which is the Electrical Power Research Institute in America, came out with an open standard called OpenADR. And ADR is automated demand response. Demand response is where you are managing the demand. So this OpenADR protocol has been released. It was built in conjunction with EPRI, and the American Power Company, and the ESB in Ireland, and EDF, Energie de France, as well, was involved in the creation of this standard. And it has now been released. So because it's an open standard that has been agreed by all these power companies and released, more and more devices will be able to use this standard to listen to signals from the grid and adjust their behavior. It will no longer be the kind of been using, it'll be available to anyone to use in any device. This is what's called peak shaving. It's taking the top off the load. So Eric Schmidt, talking about this, had a good quote. He said, I could imagine a smart garage where I plug in my car and the computer handles it. I could even make money by cost shifting. It solves energy security, energy prices, and job creation, and by the way, climate change. So there's an extra, I'm almost there, almost finished. There's an extra kind of bonus what-if question one. And this is when I pose this one and utility companies hear it, it freaks them out. What if that smart meter in your house were the equivalent of net neutral? What if the smart meter belonged to you, not the utility company? And what if the smart meter could go out across the electricity providers and choose whichever provider had the cheapest, greenest electricity at any point in time, and it select the next 30 minutes electricity from them? Suddenly you get into a situation where there's a real need for the utilities to become cheaper and greener. But with the solar prices caving, that's going to happen anyway. Yes. Okay, in conclusion, I gave you the bad news. We're in deep doo-doo. But the good news is we're technologists, and we can fix it. We've got those standards there. We've got the devices. We've got everything connected. Let's make it so. Thank you. If you have any questions, I don't know if we have time for them now. If we don't, my contact details are there, and they're in the first slide as well, but I'm happy to take questions now, Gail, if we have time.
I think we have some time for 2 or 3. Yeah.
Thank you for a great speech.
Thank you.
I have a question. You're talking about solar expanding as much as it could and getting cheaper and cheaper. But a couple of years ago, there were a lot of talks about the materials in solar panels are quite, some of them are there, and we are running out of them. How would that be?
No, it's a good point, but that's not happening anymore. Obviously, the price is continuing to come down. So they're now, they've now made, they're making all kinds of advances in solar all the time. I read a report a couple of weeks ago about they've now created a type of solar panel which doesn't require silicon anymore. They can do it with carbon. So the advances in solar technologies are happening all the time, and they're impossible to keep up with. And that's what's helping that Swanson effect keep going. So no, there's no issue around rare metals or anything like that in solar. That's not a problem anymore.
Just for the speakers of this afternoon, stand up and go in line on this side while I take the next question.
A question here regarding privacy.
Yeah.
Do you ever see privacy concerns hindering the development of the Internet of Things, or do you see convenience and corporate interests trumping everything and relegating privacy as a struggling second only meant for activists?
I think you've pretty much answered your own question there. I think convenience and corporate interests will trump any privacy problem or issues that some people might have. And you see it every day. I mean, there have been studies done where, people go into a car park of a business and say, here's $5, will you give me your password for your network? And they do. It's ridiculous. People don't value privacy as much as they probably should. So no, I think, absolutely, the Internet of Things won't be hindered to any large extent by privacy issues.
Maybe last question? Yeah, Ignacio.
We seem to rely a lot on new technologies with probably common to our countries, but probably pollution and energy problem is also quite coming from development countries and so on. Do you see a chance to make all this that accessible, that we really can fight the problem worldwide?
Really can fight what problem? Sorry.
The energy problem in itself. So over smart grids, I'm concerned about perhaps we can do that in the US and Europe and so on, but what about those development countries? Do they have the chance to get these technologies?
I think they do. I think they'll be different. So developing countries, if I think of somewhere like some of the countries in Africa, for example, they're not having to build out. They're going to leapfrog, kind of the way they're leapfrogging with mobile and not having landlines. They're going to do something similar with electricity grids. They're far more likely to have lots of small grids than one large grid. So they'll have community grids. They'll have, some solar panels, maybe a field of solar panels at the back of the town, and that'll feed in, and that'll do just that town. That kind of idea. So because that'll be cheaper to do, they won't have the same massive infrastructure costs that they would have if they tried to build out a grid for the entire country.
Okay, thank you very much, Tom.
Thanks, Kyle. Thank you.
So guys, last year I had a nice rugby ball, but I gave the last one to Michael, I think. So he's guilty. I forgot to get another one for this year. So this is a rugby ball. So You have to take it, tell your name, the title of your talk, and few words to convince people that they should attend your talk and not the other one in competition.
And will you say beep or something when they're done, or?
Yeah, and when she says beep, that's you're too long. Okay, Gunnar? Hey. Oh.
That's very good. Hey, I tried to turn Maven bundles into gold. Unfortunately, that didn't work. That's why I'm here today. But I turned them into OSGI libraries. So if you have a problem like that, show up in my talk at 5 p.m.
Hello, everyone. I'm tempting the demo gods this afternoon at 5 o'clock. I'm trying to fly a drone, combine the data to a cloud, do IoT. So a demystifying talk of IoT. Let's see how that works. Crash or burn or huge success.
Oh, okay. So Max Anderson, Red Hat. I'll talk about Docker tooling for Eclipse. A new feature in Mars comes out today. And that's sometime this afternoon. I have no idea when. See you there.
Only one under so far.
Hey, take the board.
Hello everybody, Raphaël Faudou and Guillaume Nadalin. You want to see how Eclipse and Polarsys can support you in the engineering activity? Okay, let's see the rover use case with Papyrus, RegCycle, and GenDoc to fully support. Okay, Argos in 10 minutes.
Hi everyone, I will do some basic JDK8 refactoring with Eclipse, and I will show what's inside and what's missing. Thank you. At 3:10.
Hello, my name is Steve Francisco. I'm going to be doing a talk with Marcus Nauer at 4:15, talking about how you can get important programs you're writing, working for years and years, and make them built to last with support on Eclipse, and not worrying about how you're going to make those work. Continue to work. Bye-bye.
Hi everybody, I am Davide De Cesaris of Solaire, and I will show you how to build a flexible IoT application with Cura Eclipse framework and Solaire IoT platform. So I'm here at 10 past 3.
Hello, Jean-François Roland. I will present here the scripting environment for Eclipse and how we can use this environment for modeling. And I don't remember which one.
Live coding in the cloud with just a browser. We're going to use Eclipse to write up Java applications and run them in Docker containers.
It will be with Sun and Stevan at 5 p.m. Argos room.
Thank you.
Very good. Thanks. Oh.
The last but the best talk, of course, forget all the others. I'm going to talk about how to migrate EMF models. So if you have an EMF model, you changed your eCore, you've already saved in. This is the talk you should come to find out how to migrate them. My name is Maximilian, and it's right after the keynote in the Diamond Room. Thanks.
Okay, so thank you very much. Thank you. Thanks for those who will have to do the same for tonight. So now you know how it looks, so you can be prepared accordingly. Just so now it's time to move in the track rooms. We will come back here at 5:45 for the Ignite talks. I really think that Ignite talks are always refreshing and interesting, so please stay with us for the Ignite talks. Have fun this afternoon.
I think that we can start. Okay. I'm Davide. I'm from Soler. Soler is an Italian company that more than 3 years ago started building a platform, a cloud platform, in order to build IoT application. Okay, I was involved in the development of the embedded software part of our gateway, for example, or other industrial gateway that we used in our project. And actually, I am project manager at Soler, so my purpose is to take a project from the start, from the requisite to the end and the final solution. What Soler does? Soler develops an IoT cloud platform that want to connect physical access, so physical things, physical sensors, to company business. I mean that if you have data on your platform and you want to manage those data with your enterprise application, Soler is a good alternative for you. Okay, our technology stack want to take from one side data from sensors and from machines and things, what we call things, and bring those data to the cloud, to our platform. To do this, we develop a gateway, but we are open to all the solutions. So we have an image for the Raspberry Pi, or for example for the Odoo board, or other industrial gateway. And we built our embedded application on top of Eclipse Cura framework. This because Cura is a good choice to develop application in a very simple way, in an abstract layer, without access to the physical ports and the physical interfaces on your devices. And then I will show you how to manage with our blocks in a drag and drop way to build flexible IoT applications. Okay, our applications for the IoT starts from the manufacturing industry, for example, machinery, but also we have projects in energy or smart cities. And the functionality that you can achieve with the platform starts from the predictive maintenance of the machines to the home automation or the performance management, for example. Okay, today I will show you a real end-to-end application for structural monitoring. There is a crack sensor that can monitor the linear displacement of a crack. So it can be used to monitor, for example, or bridges when they are building, or for example, heritage historical monuments. So I will explain you the basic architecture of this project. We have the sensors, like the crack sensor, and the things that for us are the breeds or the buildings. And those data are retrieved by the gateway with a wireless interface, because the sensors are an active RFD sensors. And then we bring those data to our platform, and we can manage those data in the enterprise applications that we can build with our platform. So the sensors are the Zeco crack sensor that is made by an Italian company, and it will communicate with a wireless RFD interface with the tag reader that is under the table, and is directly connected with the USB interface with our gateway. In the gateway, as I said, we developed our application on top of Eclipse Cura. And so we used the Java XCOM APIs, and we call the Solera HTTPS RESTful APIs to manage the data in the application. The purpose of this project is to monitor infrastructures and buildings' health with the linear displacement sensor, but also to detect abnormal structure movements like anomalies or, for example, disaster, and inform authorities and building owners. You can also analyze the data of the structural changes to improve the longevity and predict the maintenance cycles to your building or your infrastructures. Okay, we can start with the monitor, if the connection is okay. Okay. This is the login page of our application. So I am on cloud. The connection will be slow, but I should enter, okay. Now, what I want to show you is how to build the application on the Solar platform in a very simple way. And on the other side, how to take the data from the sensor with Eclipse Cura. So this is the dashboard of our application. These are only some links to entities of the application, or for example to a relative link. Okay, so we can start searching for sensors in our application. In this case, we have only one sensor, this one. Okay. 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 In this case, we can see some information about the sensor, so its ID or its displacement. Okay. We can set a start displacement. So when we start collecting data, we can set the start displacement, and so we can manage the variation of this displacement. But we have also information about the battery that is on board, because it's a wireless sensor. And we can change its configuration, for example, to set thresholds and give us information about critical alarms that can occur if the variation is too high. And in this way, we can see the last information about the sensor or the telemetry data. Like in this case, we have on the green the position, and on the red the temperature. And we can analyze those data to say if our structure or our building has a fail. Okay, we can, of course, go to the last 7 days of data, okay? But okay, we can see, for example, the location or something else about the sensor. We are in Toulouse. But other things are the relation between this entity and the other entities of the system. For example, the telemetry data that I show you in the property page, but I can see the table, for example, of the data. I can manage some attachments in my sensor, for example, the datasheet, okay? And I can show the datasheet directly on the cloud. I think it's too heavy for our connection today, but trust me. Okay, here we are. Okay, for example, the datasheet of the sensor and the reader. We can attach other documents. And we can see, for example, where it is installed. This is a relation that I made with another entity of the system. And this is a location entity, for example, that where we can find some information about the location details, okay, and my email, for example, or some other information. But I will show you how I made this application. Okay, if I go in the administration page, you can see some features of our platform. One is to make what we call the types. And the types are the main structure, the data model of our application. And we can have more than one application. For example, in this case, we have only one application, but I can build other application in the same tenant structure. Then I can model some workflows. For example, say to me that there is a critical event, and I want to inform the building owner or the authorities about these critical events. I will show you. Or we can build some reports. For example, I made a sample report about the Gecko sensor. This is only an example of the average variations of our sensors. In this case, I have only one sensor, but I can modify the graph according to the data pool of our entities. So coming back in the administration part, we have the integration tools that can manage a third-party system like CRM or ERP, for example. And okay, in this case, this is our types, okay? So we have configuration, location, document, the gateway type. We have some sensors as the Gecko that I bring here. But we can also see the data model. Okay, so we can see our types connected together. And I want to focus on the measure group types that are linked to the sensors. What we call the measure group are group of measures that the sensor will send to us and that we can manage, for example, in the property page that I show you. These are the data about the measure group that are linked to the Gecko type, for example. But also we can have configuration that we can update dynamically, okay, in our sensor and in our device. For example, changing the data interval or the sampling interval that the gateway pulls the data from the sensor, or for example changing some thresholds or some values of the sensors itself. For example, if I open the GECO part, I can show you how to extend, for example, our types, simply dragging and dropping what we call concepts. The library concepts, and it's more than 100 concepts actually, and we can take this concept from the library on the left. Okay. For example, a double concept or a string concept that are base concepts, but we have also some other concepts like scripting concepts or date concepts. Okay. For example, we can drag a double concept. Okay. I have the connection is not so good, but we should drag a concept here. So I build this type with using our library concepts, and in this case I cannot release because I think that I want to show you a concept on the grid. For example, a string concept. We can modify the concept, for example, in its label or in its advanced features, like if it can have a default value or a max length, for example. But we can also reference a cell of our spreadsheet. In this case, the spreadsheet is an advanced tool to take data from the linked types, or for example, to average a value or to calculate some percentage of the values or some modules, for example. So we have a tool to link the data between the types. So I can refer, for example, our measure group of the GECO and take by the timestamp in the descending order the first timestamp interval, or for example the first average value of the GECO position. Okay. So I can access to the data linked to this type, so the GECO, for example, the measure group, in a very simple way, using the cell of a spreadsheet. Okay. Now I want to show you, if I can, how I can change, for example, a threshold on our configuration on the GECO. In this case, I modeled the GECO type and the GECO configuration with some simple values. For example, then the type, we can choose the other tag, so the other sensors of the same manufacturer. Or we can change the sensor range, because this linear displacement is from 0 to 25 millimeters. Or we can change, for example, a threshold about the alert. This is particularly important because if we change this value and we update this value, the gateway will be informed about this change, and will send us events about this alert when the sensor overcomes the 12, for example, millimeters. How I can do this? Okay, if I open my bundle on Eclipse Cura, I will show you, for example, okay, in the sampling function that I will take the data from the sensors, in this case with a proprietary protocol that I implemented because it is very, very simple. And then after getting this data, if the data is overcoming our threshold, I will send an event. Sending an event to our platform is very simple because we can only have to create an event saying which kind of event it is and send the event using the Solaire client. So in this case, we have developed a bundle in the Cura framework that you can use to develop our application in a very simple way, as I show you. For example, to send what we call the measure group. Okay. Here. We can only create a new measure group, okay, like this, saying which type of measure group we want to create and the data interval that those data refers to. And we can send the measure group using the same Solaire client that we create in the initialize procedure. In the initialize procedure, we create the Solaire client saying only which server, in this case the production server, and in some other flags about the debug operation. And the gateway will inform our platform that he is the gateway with this MAC address and can communicate with us. If it was already allowed on our platform, it will receive information about, for example, the sampling rate, or the data interval rate, or the command interval rate, or other stuff, for example, the threshold, and the connected things, for example, these tags, and it can start to communicate with us. Okay. Coming back to the presentation. So, which are the results? Solaire with Cura can integrate your sensors or standard sensors in a very fast way. For example, in this case, we used a serial protocol, but I took a few days to implement this protocol in Cura. But we can also change dynamically the configuration, as I show you, and extend our types, for example, dragging other concepts. And for example, if this sensor tomorrow is able to take also the pressure, we can only dragging and dropping another concept for the pressure and saying to Cura to take this new measure. So it's extremely dynamic. And also we reduce the time to market. This because we can make our application in a few steps on the cloud, but also we can make it very simple with Cura. So we apologize some scenarios about the structural monitoring. For example, about the civil engineering, for the crack detection or the impact monitoring. And we can improve structural safety in this case, or detect damages with structures that are in service or are in building, and prevent the downtime and future disasters. Other applications are about smart buildings, for example, where we can integrate this data about the crack with the vibration data or the pressure data inside and outside the building. And in this case, we can analyze how the frame of the building changes, and in this case, improve the structural longevity. Another scenario is about the heritage building that is particularly important in Europe, for example. And we can monitor cracks and the humidity of our heritage building to optimize the long-time restoration planning, or, for example, to have an accurate picture of the structural properties of our buildings. This can build, as I show you, in a non-intrusive monitoring with these sensors. And we can have a measurement of environment variables in real time, every time using our cloud platform. So, I think that we have only a few minutes. If you want to join us, think of an IoT business application. Write an email to our developers account, developers@solaire.com, solarcorporate.com, sorry, and email us about your idea, about the functionalities of your idea and the number of connected objects that you want to bring to your application. And then, if your idea is particularly interesting, we ask you a blog to write a blog post on our blog describing your application, and we will take you a tenant to prototype your application and to bring this application in very few months to a business area. So, thank you for your interest, and if you have a question, I am here, and I will be glad to answer your question. Okay.
I never worked with Cura before, and I didn't really understand what did it do really, what kind of
Okay.
did it bring you?
Okay.
This piece of code, what I saw is that you completely manually
Yes,
parse
yes. There was only a few minutes, so, but Cura is a framework that is developed on top of the Java OSGI Equinox project, and you can build your bundles, your application bundles, and for example, I will show you better. In this case, we have this. Okay, I have some code that I show you, okay, about the initialization of the bundle, the activate method and the deactivate method, or the updated method, that are called from the container itself of the OSGI. And you can, for example, connect to your device and install these bundles in your device. I can show you, if I know the. When
you say your device, that's your gateway, right?
Yeah, our gateway. But you can prototype your application with Raspberry Pi, for example, in the website of the Eclipse Cura community. You can download the image for the Raspberry Pi and start from the scratch.
It must be ARM, right?
Sorry?
It must be ARM processor, right?
Yeah, it is an ARM processor. In this case, we have I think that now Cura is compatible with Raspberry Pi, the BeagleBone, the Intel Edison, for example, in the last release. And you can, it's an open source project, so you can download the source code and compile from yourself if you have another architecture. Other questions? Nothing. Okay, thank you.
Okay, so I'm Max Anderson. I'm here to talk about Docker tooling for Eclipse, while everyone else downloads Eclipse Mars, which just got released. What I'm going to cover is a little bit of Docker. Who in here actually uses Docker? Who in here knows what Docker is? A little bit more, okay. But I'll cover Docker a little bit from the developer side. Docker is a lot about operations and DevOps, where I'm kind of focused more on what's useful in here for developers. And then I'll show the Eclipse tooling we have made for Docker, which is now available 15 minutes ago. So first off, what is Docker? On Docker.com, there's this very vague description saying, Docker allows you to package an application with all of the dependencies into a standardized unit for software development. I've heard that song a bit too many times before. So like a WAR or JAR or DLL or RPMs or even an OVF, which is a virtual image disk, that's the same thing. So Docker is a bit more than that. So when you have Docker running, what you do is you can actually put containers inside Docker that runs, and these containers can actually run all this old stuff. Well, it's not old, because Docker actually keeps it relevant. So whether you're using RPM or Debian-based systems, or a jar guy or ear guy, or you want to write a little Ruby script or whatever, Docker can be used together with it. Right? That's the thing here. This doesn't require a new container, a new application container. It can host anything. And these containers then has a standardized way to talk to each other. And which high technology way are they using to talk to each other? And environment variables. That's the high technology feature. So basically what you do is you can run this container, and each of these containers can say, I want to talk to this guy or this guy. And then they inject variables into that system that says, okay, where is the port and where's the connection you can listen to? And that's it. That's what they do. There's more details, but I'm coming from a high level here. But from a developer, that's what they do. So what this gives you is this standardized unit, a little container. It has a really simple tool chain. And in simple, I mean it's pretty nice. It's very easy to use. There's a few commands that you just need to learn. Like there's Docker build, there's Docker pull, and Docker run. If you know those three, you're almost good to go. It's semi-portable in the sense that you can run the Docker client, that is the one that talks to the Docker daemon, on Linux, OS X, and I think even Windows now. What is not so portable is actually the engine. But what people have done is that they've run, Docker runs natively on Linux, but you can actually, here I'm running on a Mac, so it runs in a virtual machine, and on Windows, it also runs on a virtual machine. And the thing is, because of all these up here is already machines, it doesn't really matter. It's the same the same thing you have to work with, it's small virtual machines. But of course, I know Windows, Microsoft, they've now started so they can actually run Docker natively on Microsoft too. But the point is, it's a standardized unit that's going on across the whole industry, on all the platforms, and allows you to package both existing things, like wars and jars and ears and whatever new comes up, right? And then the thing that really, all these three has actually been done before, right? A virtual machine from KVM or VMware or whatever could do these three things, run on all platforms, etc. But they were gigantic. Like you have to ship 4 or 5 gigs of data, and they all had their unique way of doing things, and it was super slow to distribute and package. Where Docker goes really good is it's super fast. Like you can start up these things in seconds, and the way you express how to get things is so lightweight that it's like you have to try it before you actually understand the impact. And I hope you'll see a little bit of this today. But basically, for me to actually understand Docker and why it's interesting was the day I actually tried it. And you go like, oh, this makes a difference. Because the difference is you can start and stop these, ton of these without any I can't say it anymore. Any big burden. It's very lightweight. Okay, so the Docker parts we're going to cover. There's a Docker file, which is a simple text file, where you put some commands about what you want to run. So here's one that says, I want to base my Docker file on another Docker file that is Wildfly. Wildfly is the application server from JBoss, Red Hat. I want to add some, by the way, this is pseudocode, but it's what it looks like. I'll add some configuration files. I want to run some yum install. I want to install JDK 9. And then when this Docker file starts, I want to run the start SSH file. Very basic instructions that you can configure how it works. This Docker file then gets built into an image. And this image is actually the thing that you ship around. And this one can get big. Right? This is where all the dependencies are in. But still, it's much, much smaller than a full virtual image would be. It's only the stuff that you need to run this thing. And then when you run an image, you get what's called a container. And the container is the thing that is actually executing your thing. So those are the artifacts that you deal with. And then the nice thing is that these images can be sent up to a registry. And this registry can then be searched. So if you heard about Docker Hub, where you can go and look up any kind of image of like Postgres or Wildfly or RHEL or Ubuntu or Fedora or specific little apps, that's what that is. That is a registry where these images are. So that means you don't have to start with a Docker file and need to learn how to build this thing. You can just go, hey, I want to play with Postgres. And go Docker pull Postgres, and it will get you Postgres. And then Docker run Postgres, you have a Postgres server. No need to read any long manuals, etc., about how to configure it on your specific OS, because this is just running inside your machine. You don't have to think anymore, at least not on this part. So it allows you to get started very quickly. And then the container is actually running inside a daemon. The daemon is one that controls these processes that actually that are these containers. So what you can do with Docker, I covered some of it, but the main thing is these apps run in isolation, or more or less isolation. So they don't automatically have access to your file system. They don't have automatically access to your network or anything. So it's almost very safe to run anything, because something people tend to forget is if I'm going to do Docker pull some image from Docker Hub that no one actually checked, I could be running anything malicious. But by default, Docker apps runs pretty securely. But of course, if you start opening up ports and you haven't checked what you're running, then that's a problem. But again, from a developer perspective, experimentation and exploration of applications becomes so much easier. So the one that I think is the main thing that gets talked about for Docker is that you can deploy your apps to a server, a container, that runs exactly or very similar to what your production is in a super fast way. Right? So you can imagine that your production or your operation guys have defined, here's the Docker description that we use for running our application, or maybe multiple of them, and you can just take them on your laptop and run them. There's no virtual image you have to explore or copy over, etc. It's just there. And again, the really important thing, the one that took me a while to realize, is it's so fast. And again, you'll see this later. The other one where I think it becomes more interesting for me as a developer is I can use Docker as a basis for build slave of Jenkins. Right? One problem we have, at least in Red Hat, is we have a huge Jenkins cluster. Apparently, it's one of the biggest one on the planet. But they are today running as, I don't know how many machines, but let's say a couple hundred machines, which is virtualized and run virtual machines inside them. And that took a long time. It takes a long time to get them set up, and we have to always open a request about which packages and images we have to have run on them. And it's just a burden. Now we're moving towards having they still have the same machines, but instead of having, all our machines are configured this way, we can now, each project can say, hey, I have this Docker file at a certain name, it's configured all the things I want and nothing else, And now the operations guys, the only thing they have to do is provide the hardware and the OS that can run Docker. And then the ownership and setup of the machines come back to the developer, and we can do it on Jenkins as we want, and we replicate it exactly on the laptop again. And this is very powerful. But I'll spend most of the time on the rest of the talks is this fact that I can experiment and set up different things on my machine very quickly from the IDE, where I can experiment with different databases and different containers, application containers. I'm going to use some very basic Java EE here, but it could be anything. It could also be MongoDB and a little microservice, whatever. But the fact is I can get stuff up and running very quickly. And I'll touch a little bit on the fact that by putting Docker into Eclipse, we can actually use Docker as a build system. So for example, this Mac here cannot build binaries for Linux. I'll have to shell out to some machine that can do it for me. By Eclipse actually having the ability to start up Docker images on my machine, I can now suddenly delegate the build job to a Docker instance. And there's more possibilities, but these are the ones that I find interesting. Okay, so Docker at Eclipse. So this is a project in the Linux tools project, and just to clear it out, it says Linux tools in the product, and 90% of the stuff there is specific for the Linux, but the Docker tool runs equally well on OS X and Windows. The only reason why it's in Linux tools is that the committers that did this was committers already, so we can get it into that project before for Mars. One of the plans is maybe to move this out so it becomes more visible. But anyway, it's at Linux tools now. Don't be afraid, it runs on all other platforms too. And the goal was, again, to make Docker accessible from Eclipse and do it in a way that it still works with all the existing tools. Because I just said that all the CLI tools that are there are pretty nice. But we want to make sure that it works with those things, like Docker Machine or Docker CLI, or if you know Docker Compose. But then we, of course, why are we putting into Eclipse? There's two reasons. One is that a CLI can only get you has some strengths, but having a visual access, a UI access to Docker is nice, and I'll show some of that stuff here. And the long-term goal is that these things can be used by other plugins. So I'll show how we are planning to doing it for the JBoss tools project I work on. I know that the CDC tools are doing this remote build thing, and I can imagine guys like the PHP tools or other Eclipse plugins, even outside Eclipse ecosystem, have a benefit that they can actually just go, there's Eclipse API to say, I want a Docker image here, give me the connection, and off I go, I can do my thing. Okay, so to get started, and this I'm not going to dwell much, but first of all, you need to have Docker running either on a machine next to you, but you need to have, the recommendation I have for you is to use a thing called Docker Machine. It's from Docker. If you used boot to Docker before, that's kind of the old version. Docker Machine is like the new generation. It works basically the same way. The little sidekick is that you can actually have multiple Dockers on with Docker Machine. But anyway, if you used boot to Docker before, use Docker Machine. It's more up to date. It's a bit more flexible. And I'm just going to let you know that one of the things in Eclipse tools we do is we detect your settings. We try and make it so you don't have to do anything. But for us to know what Docker configuration you're running, if you're not running on Linux, because on Linux there's a hard-coded default that we can just go look. If you're running on OS X and Linux, we need to know your Docker host. And if you run this thing that says Docker Machine env dev, it will output the settings that you should evaluate, and therefore it becomes up in your environment. If you have that running, it becomes much easier to use the tools. And then this is optional, but just a tip that helped me a lot is I have in my host file on this machine the IP of my Docker host. So that means if I use the browser or anything else, I can just write Docker host. I don't have to remember which weird IP it's on. And then the part that is interesting here is you can either go and install the JBoss tools and tools.jbos.org I work on, where we have Docker shipped, not Docker, but Docker tools shipped there, or you can use the Mars release train today and get it from there. And this should work out of the box. All right, so let's go and see if I can get this running for you. And I'm very sorry, but the resolution here is very low. So I hope you can imagine this will look better on a big screen. But you should be able to see the details. So anyway, there is a Docker tooling perspective that gives you this Docker Explorer, some Docker container and Docker images, which I can't see on the screen because it's too small, so let me go back to the one I have prepared. But basically, we have used a tree that's called Docker Explorer, here called Doc, where the connection to your Docker is. And you can have, so the way you start is you go plus, and what the tool will do is try and detect those settings I talked about, so you don't have to type anything out. I'm running on OS X, and this is a typical way it will detect. There'll be some IP on your machine. And the reason why can't I just put the TSP, the connection in there? That's be easy. Why do you need to auto-detect it? Is there's this other part with certificates. For security reasons, a default boot to Docker or a setup so it will be secured. So that setup you want to avoid, you have to go through. So anyway, if any of this doesn't work, you can just go in and override the connection. And mind you, this does not have to be a Docker on your machine. It can also be something separate, a separate instance. And you can have multiples. Anyway, I have it already here. I have my boot to Docker Explorer. I have no containers, but I have a bunch of images just because I don't trust the internet here. But let's say I didn't have any images here. Then, where is my Docker image? There's a Docker image view here, and there's a pull. So I could actually go now and say Postgres version 8.0 and press finish. And again, I'm not going to do this here because of the internet. But if I press finish now, it's going to pull the image, and I can use it. It'll become available. Right, so normal pulling is available in here. So once I have the image, I can browse into the images. I can also go, let's say, where's my Wildfly? Here. I can say on and run. And actually, in here, let's see if this works actually. I had problems before I got up here. Oh, there we go. Here it was actually, I was looked up via Docker Hub, the Postgres images, and there's, I don't know, a ton of people. And let's see, there's a Postgres here that says it's 786 stars, and this is official, so that's probably the good one to go with. But there's other people that have done other stuff. If I go Wildfly, I think that's the same kind of thing. Unlock now. Okay, so once I have it running, not running, I have this run with it, I can give it a name, I give it a command, and I don't have enough. Okay, sorry guys. I forgot that this display is big, so I'm just going to do this. So you have to imagine you can read the text now. Okay, let me just resize this thing. Hi. Sorry, too small, but I hope you can get the image of this. I have the name, I can ports. So this instance of Wildfly only explores one port called 8080. It gives me the ability to either just say, start this up and run it on some random port. If I unclick, say publish, it's going to take the default port and make that exposed. That's the same name, same number. And then there's some data values, environment variables I come back to later. When I say finish, it actually is going to start my server down here. And then if I go to Docker containers, you should see there's an environment running less than a second. It says port 8080. If I now open my browser here, it says, oh, sign up. I'm going to put Docker host, because remember I put the Docker host into my host file. And I have to type HTTP here. There you go. Now I have Wildfly running on my machine. Right. Same concept for anything else. Very easy, very fast. I didn't have to figure out where to download Wildfly. It just is there. Okay. I think that was the basics. Oh yeah, the other thing I have, the properties down here. Details about the images. So for example, or containers. I can, it's a thing called Docker Inspect. Docker Inspect gives you all the details that this thing has. And you'll see, I can get what command was run, which environment is running, and all kind of other stuff. And this is, good for copy-paste the information you need for any setup you need to do. Okay, so I only have a short time, so let's get this running. Yeah. Okay, so the next part is going to be a bit tricky, so I'm going to walk you through what I'm going to do before I do it. What I'm going to do is I have my local host running. This is the machine. I have Eclipse. You saw that. I'm going to talk to Eclipse and start up a Postgres instance. I'm going to start the Wildfly instance too. They're going to talk together. And the Wildfly will be exposed on 88 as before. And the Wildfly will have a deployment. It's the way I can put deployments. And then Postgres, just for fun, I'm going to connect via the database tools. And then the trick is that one thing you maybe heard about Docker is that the images you're running or the containers are immutable. You cannot change them. So basically the default approach is that you actually, in your Docker file, you describe what you want to build, what you want to put in. But if you're in a development scenario, it's a bit annoying having to wait for the build to run of your jar and war or whatever, if I could just put it into the deployment of the server. So in this case, I'm going to use what's called a volume mount and saying that the deployment on my disk pick up. Docker container is going to pick up. Right? Oh, wrong window. So I'm just going to kill this thing, because that's the nice thing, these containers, I can just kill them. Gone they are. Boom. No one's seen it. All right. So first, I'm going to start the Postgres. I already have it. I'm going to say run image. I'm going to give it a name. No, I don't want to give it a name. I publish the port 5432. And here I'm going to set environment variable. So this Postgres instance expects me to set the password on the instance. And the way you do that is you go Postgres password. And you go secret, which is my secret password, so don't tell anyone. And I say finish. So now I have a database running in Docker. Database run. Yes, that was what I had. I prepared already a connection in Eclipse that goes to Docker host 5432 on a Postgres connection. If I go connect, I now have connected to this database. And you will see down here somewhere, oh, wrong one. This public one has no tables, so nothing is stored in there. Right? Next thing, I want to run Wildfly, but Wildfly doesn't have any information about Docker. Wildfly has no information about Postgres, so I need to tell it how to do that. So I've written a Docker file, and I'm not going to go walk you through this basic thing, but what it does, it takes the Wildfly image I had before and adds in a Postgres driver and tells Wildfly, this is where the driver is going to be, and then it exposes another port, which you'll see, but we don't use it. But the point is, I'm tweaking my Wildfly images to be what I want it to be. And what we can do is, here's my product with these files. So there's a Docker file and the other files I need. And I can go right-click, run as build image. So I'm not going to do it now because I don't have time if it fails. But it'll run that script. And because I already have the image from Wildfly, the only thing it's going to do is add those files. It's going to be very quick. And I have a fully configured, controlled environment. Right? So I think if I can do this, yeah, I can put the name I want to do, where it should go, how it goes. But anyway, trust me, it will work. It can run. Okay, so now I have an image. I have my Docker. Oh, sorry, there was one little thing you might not have missed. This thing here, it's a standalone XML, which you don't need to know, but basically that's how you configure Wildfly. You can do something similar in any other setup. So in here is a data source that says, you can't see it here, but it says $env db port 543 TCP address. So this is this thing about linking the two containers together. They don't know they're running in a container. They just know I need to look up an environment variable. That's what this one does. Right? And notice there's this, it says db underscore. That's the link I'm going to define in 2 seconds. Okay, so I'm going to go JBoss Wildfly. I have this thing called Wildfly Postgres. I'll say run image. Okay, and so I'm going to again the ports. You'll see now it's 99.9999. Doesn't really matter, just I can extend it. I'm going to link to another container. This is, sorry. You see over here it's called Furious Einstein. Awesome name. That's my database. The alias DB, which was this DB underscore I referred to before. I say OK. Then there was this deployment location I talked about where the server is picking up the details. I'm going to say, yes, I want that enabled. And where's my notes? There's a path I need here. And I'm just going to point it to this directory. Say OK. And then this server also needs to know what the password is. So I'm going to put a Postgres password, secret. Voila. Off say that this server should, instead of deploying to a specific server over any remote API, whatever, I'm going to deploy to the file system. So this one is using a custom deploy folder at a specific location, the same I mounted. And it's told to not do anything, just assume it started. So when I say start, it is already running. And if I say, now I can do, instead of having to know how to do this, I can show web browser. You'll see it opens up on Docker host 8080 using standard Eclipse tooling. I have an application running, this kitchen sink I deployed over here. Again, this is plain Eclipse tooling, no fancy weird things. And just to prove that it's actually linked, so I have this app running. There's the data. If I go to my data source explorer, I'm going to disconnect and connect again just to get this one to fill up. You should see here tables. Oh, there's a new table. So that my server doing startup went to Postgres and created the data. And just to show the deployment actually also works. So here is my index page. There's something here, JBoss and Wildfly. Let's say JBoss at Docker with EclipseCon. I save the file. You notice it do the deploy. If I now go and reload, boom, that was actually deployed in there. Right. I know this goes fast, but just showing that these are actually connected. It's very fast. I didn't do anything. And just to do the final one, blah, blah, EC something numbers, I can register. Oh, not valid. Did I paste something? There you go. Put data in. Let me go and sample content. It actually is there. FDF. Oh, I did. Let me go and edit it and say, yeah, I'm actually Max with a big M, Max Rydell Anderson. Yeah, save, close, go back to my, there we go. Right? That's it. That's what it allows you to do. And I didn't actually have to install anything except Eclipse and Docker. I didn't install Wildfly, I didn't install Postgres as you normally do. I just used the Docker images. All right, I'm actually running out of time, so let's be even faster. Again, just to remind you, I had Eclipse, Docker, start the Postgres, had the Wildfly, connect to the Postgres, expose to the port, I exposed the thing, I could talk to the database, and I over the file system, I made sure the existing tooling I had could deploy to the server, and voila, that's it. Yes, so I've been able to manage these Docker containers very fast, very quickly, and of course I knew how the tool works, but generally using this is actually, for me personally, easier, because I don't have to remember the CLI or whatever is there. I can start and stop them, and I can link them together in Eclipse. I can deploy Java EE application very easily to these things. This could be a PHP app, it could be a Ruby app, anything. This was just Java EE in an example, but there's no magic here. It's just file systems access. So any tool in Eclipse that can deploy to a directory, you can hook up to a Docker tooling. But big type where you can actually build and run native apps on Linux this way. And I hope there'll be more use cases that will be presented to us that we could explore. Short term for Mars SR1, maybe you didn't notice, but I was actually typing a lot in this thing about the environment variables. If I have to rerun my thing, the stuff I have to type in again. We want to remove that. So in SR1, this comes in 3 months. A lot of these extra steps you have to do, we're going to optimize, it's called. So it becomes simpler. Longer term, we don't have a fixed schedule, but somewhere in the Mars timeframe, we want to make sure that either Eclipse or at JBoss tools or in the Red Hat tools that we can use Docker as a target for Java, Java EE, C2T. The builders, we want to integrate our stuff OpenShift Kubernetes to do more like clusters of Dockers. And on the plan is, we've actually had already 2 contributions about Docker file editors, so it doesn't become this very plain gray one, but a more colorful one that can do content assist, etc. And then I had other containers, because the thing is that Docker is not down. There's more coming up. But actually this week we just announced that Docker and those guys are moving back together again. So I could imagine that stuff like Open Container that's coming out now will be a thing that we support in the future. Okay, so here's the URL. It's just tool.jbus.org is where we get the JBoss tools. That's what I use for the Wildfly control. Eclipse.org, Unix tools, it's a project where Docker is. Docker.com machine is what I suggest you install if you haven't tried this. And then the Docker file, etc. I used for the example is at that GitHub URL. Good. Questions? All was crystal clear. Spoke too fast? Maybe. No? That was boring. All right. Well, there you go. Thank you.
Yeah, so I think that if the other one could be here as well, maybe just hang around on the lower level somewhere, if and when it escapes. Looking good. Just a couple of minutes. On both sides, I guess.
Okay. Catch it and put it back into.
Yeah,
So if it goes over there, it's yours. If it goes over there, it's mine.
yeah, if it escapes.
Am I dressed for the throw?
Oh, yeah, you can do parallel. If you catch it in the air, you can just tilt it over and then it jumps down.
Pulls me up.
People have been blinded by drones at conferences. Do you know?
Sorry?
How many people have been blinded by drones at conferences? Do you know?
Well, they never catch me when they they was all around it. Okay. Are you guys recording any of this stuff, actually?
You can quickly go and take your phone. If anybody takes pictures, you can upload them to the Flickr group. It'll be on the website.
Yeah, question. Are you recording this system?
Benjamin, are you recording?
What about voice?
Where is it? Oh, there it is.
Okay. Okay, I can try that. Okay, these are working as well? So I can use this one? Okay, all right. Okay, I guess we can start. So, hello everyone, and welcome to the talk of the evening where I tempt all the demo gods possible. So let's see how this will go. So my name is Ville Engman. I'm a Finnish guy, lost in France at the moment, and I work for a company called Vaadin, the Vaadin framework. How many of you have actually heard about Vaadin before? Few hands, awesome. So I work for that wonderful team. And what I'm here today to talk about is something that I like to call, demystifying IoT. All the talks that we see about IoT they're either really, really abstract or they are really detailed. So I try to put up a kind of full setup with the basic building blocks and really make it as simple as possible. So this is the whole thing. So how many of you have actually done any IoT things? Few hands. All right, good. Okay, but let's get the show on the road. So, first things first, of course, relevant Twitter accounts and handles that you guys should be using. But nevertheless, if you actually read the talk abstract and the description, this is probably what you guys felt, especially what I felt when I was doing this whole thing. So how can I actually fit all this stuff in one talk? So let's see how this will go. So there's quite a lot of cool stuff here. Anyway, so the talk is in 3 parts. First, we're going to go through with the real-time data, with drones, of course, and what I mean by real-time data. And after that, we're going to put the whole thing up
to the cloud, and I'm going to use the IBM Bluemix cloud for this example. And at the end, I'll show you guys how to visualize the data that I'm getting from the drone. So, first things first. So what is real-time data? So what I mean by real-time data here is that you monitor something that is happening right now, okay? So these could be the examples of real-time data that you might have, like some factory processes or sensor data or whatever it might be. But for an engineer, it's pretty cool because all of these are just numbers that are coming right now from somewhere. So it's really simple for us to handle this kind of thing. It doesn't matter whether it's a factory or a temperature sensor at our house, we can treat it the same way on the programming level. So I think that's pretty cool. But I'm not talking about kind of long-term data and see the trends from that. That's a way another thing. You guys can do that by yourself. But I'm talking about data that is happening right now. Okay, and I couldn't bring you guys a factory process here, so I brought you guys a drone. So this is my real-time data source. The only reason why I brought the drone was that it's a drone. That's the reason. Okay, so let's start building the whole setup. First of all, surprise, surprise, we have the drone there, but what else we have? So the setup here is that the drone is connected to my laptop through Wi-Fi. Okay, my Wi-Fi is taken by the drone, and in this Wi-Fi connection, there's a constant data stream coming in from the drone to the laptop to get the data. So I have this little Swing app on my laptop where I sample the data twice a second, what I'm getting from there. And the app that I'm using on my laptop isn't made by me. It's open source project, I guess, from Germany, the YaDrone, called the Yet Another Drone software. And I just took it out from version control and made a fork of it, and that's what I'm using. So if you guys have a drone, you can take this in as well and play around with your laptops. All right, let's see the raw data. Okay. So what we have here, so I have my Eclipse here, and Eclipse is the YaDrone software is running on my Eclipse, and the YaDrone software is looking like this, and I have my keyboard control there, and let's see, is the link still up? Actually, one little request I forgot to mention, you guys. If you all could close your Wi-Fis from your mobile phones, that would be great. Because this is a pretty shaky environment. There's Wi-Fi interference going on, and that's why I have these two lovely volunteers, the drone catchers here. So if and when the drone actually escapes me, they will catch it. So I always like to say that, everyone knows how obedient dogs are. Sit, go and fetch a stick, they'll do it. But drones are like cats. Maybe. So you might get a haircut today. So if you do, it's only $20, so it's cheap. So let's see how this little cat will obey me tonight. Okay. So let's put this up. All right, let it stabilize. Well, the cat is behaving. Or not. Or not. Come on. This way, this way, this way. Well, and it's gone. First try. Like I said, hey, I like cats. Let's try it again. Okay. Okay, it stabilizes here somewhat. So here is the live data stream coming from the drone. So the data that I'm gathering here, you can see that there's a battery level out there, there's the altitude in centimeters, and also the orientation of the drone. So this is what I'm sampling from the live data stream that is coming there. Okay, let's put this down before you lose your head. Okay, somewhat okay. All right, but this is the data. As you can see, it's JSON, okay? So I just put it in a JSON format. So this is what I'm getting. So next step is to actually get this data out of this classroom. So let's continue with that. Okay. So the cloud thing. How many of you know what IBM Bluemix is? Few hands. In short, it's the cloud solution for developers by IBM at the moment. So why I'm using Bluemix is that in all Internet of Things environment and IoT in general, you need the communication mechanism somehow. So I'm just using a service that is available for developers in the Bluemix cloud, just to put up their IoT broker. So this is the IoT broker from the Bluemix cloud. So what it actually does is that it's a server. Okay, it's just a server where I can connect with my data sources, and also I can connect with the actual apps that consume the data. So this is the setup. It's just a server, but the good thing is that, of course, it has to be accessible all over the world. There has to be all the connections and everything are available there. So it's just click and click through, and you have your server with all the addresses and all the things that you need for the credentials and authentication. They are there for you. Just take them in. So that's why I'm using it. So the building blocks after this one is the cloud that has the server in it. Eclipse has actually the M2M server as well that you can try out. Same thing, but this is kind of more dedicated to myself and not for common purposes. So cloud setup, there's the IoT Proco server set up there. And what I'm starting to do, I'm using MQTT for the messaging. And this is awesome. I love MQTT. Also invited by IBM, I guess. Any IBMers in the room, by the way, to take all the credit? No? Well, too bad. How many of you have MQTT? Probably the same guys that actually did the IoT. But anyways, I love it. It's so simple. So for a Java guy like me, Eclipse PAHO is the project to save my life here. So it's not only Java. It's pretty much all the programming languages that you can think of. You can use MQTT. But the PAHO project has a really nice Java libraries and Java APIs for that. Any PAHO project members here, by the way? Well, I give you credit. Ah, did I see a hand? No. I was just trying to give my, gratitude for you guys, and no one says that, yeah, I'm in the team. Anyway, so in practice, the only thing that I have to do in my app is pretty much like that. All the Java that is needed to actually do MQTT, and I think this is awesome. I just put up a client, few connection options, and then I start publishing data. To any topics, they can be any string value and any kind of message, and it goes out. That's it, all needed. Even I can do that, so that's pretty fun. All right, so let's see this whole thing again. If the internet connection is actually up as well. Okay, let's see. So this is my IBM Bluemix dashboard where I can have the whole thing, and the Internet of Things is, as a service, is here. Well, the internet is probably not working. Let's see. No. That's nice. As you see, the internet connection has been up and down lately. And also gives me a headache if there's no internet connection and I have to use a cloud service for something. Come on now. Nope. No bananas.
Does the data get cached locally?
Good question. No, nothing really. No, nothing happening here. Establishing, waiting. Maybe? Almost? Okay, I can come back to this at the end of the talk as well if it doesn't really work. Okay, let's save some time. I'll try to do this actually afterwards when we come back to this. I can show you the UI part. So that's the IoT thing. So the MQTT messaging and the finding an MQTT broker is the key to the success with IoT. But let's look at the next part, the dashboard. So this is where the whole thing comes alive. So Vaadin, I work for Vaadin. Of course, you guys need some way to visualize your data when doing IoT. One option for that. So Vaadin is from Finland. It's actually a Finnish name, meaning a female reindeer. So probably the logo makes sense after this one. But after all, what it is for you guys, it's an open source Java API for building web apps. Okay. How many of you have done something with Swing? Java Swing. Well, almost all, I would say. So you already know pretty much. It's the same concept, okay? Only Java components, but the end result happens to be HTML5. That's the whole thing, in short. So what Vaadin is, it's basically a building block, set of building blocks. I like to say that it's kind of a bag of Lego bricks. All the Lego bricks fit together, and you can build whatever you want from them. If you want to change some piece from the structure you have built, just do that. It's a set of components. And the good part is, for Java guy like me, I'm not I don't know Java, of that stuff. I don't want to fight with Internet Explorers, for example. And the good part is that with one implementation, I can support all these browsers, even mobile browsers. So that's productivity boost for me when I'm doing projects. So the Vaadin ecosystem, we estimate that we have around 130,000 developers using Vaadin already globally, and it's Apache licensed. The biggest area of Vaadin users are from German-speaking countries, I would say, and almost half of the Fortune 100 companies already using our tool for something. But the most important thing is that it's for business apps, web apps. No one does a homepage with Vaadin. It's for application development, web application development. So this is important to understand where a framework fits and where it doesn't. So is the thing that we are concentrating. And what we try to give you guys as a developer productivity for, of course, the number one thing. And on the other hand, the rich user experience is another. So everyone knows how awesome Java guys are to actually design user interfaces. So we all know that. So we at least try to give you guys, good-looking components and the set that you might even get there without the help of UX people. So even I can do that. But that's what we try to accomplish. But I actually thought that I skip all the slides, you guys. So I'm doing a simple app. There's a menu on the left and a couple of chart panels in the app. So you can actually see how the Vaadin programming looks like. So let's go here. I guess everyone can see this pretty big, right? So this is the simplest Vaadin application that you can find. What we can learn here is that we extend something from the Vaadin library, and this is technically a servlet. So this is server-side programming, all Java and nothing else. And there's only one method that I have to start using is the init method. And here I just set the content being one label. And let's see if I can actually fire this up as well. Let's see. Well, what do you know? I got the hello world working. Eclipse Con rocks. All right. So this is the Vaadin programming, how it looks like. But let's do something extra. So let's put up the main layout for the whole thing. So everything that you can see here now that starts with my is something that I implemented for you guys for this talk. All the other things are coming from the library, okay? And if we look at here, what the main layout actually looks like, it's just a composition of a few other components, few layouts, and say how they behave. This is all to it, how they are organized. And that is the main thing here. Next up is the menu. Oops, sorry. Talk menu. So, again, my menu, having the title, few menu items here, and if you look at how it actually looks like, my menu is really simple. When I actually add a menu item there, actually I create a button, and I style the button a bit, and put it to the actual layout that is behind there. But as you can see, pretty straightforward Java programming, not too complicated. And also, here is the listener thing. I'm going to be the class that listens and clicks menu. So let's just show a notification. All right, let's restart. Next up, come on, go away. Next up, the panels. Come on now, go away. Talk, top, there we go. And the other one, the bottom. So 2 panels here, again, something I implemented for you guys. This is all that is to it, what's the sizing, how it's organized and all that. And the data API that I'm having here, I just have a copy-paste from our charting examples. So this is just Java code again. Let's make the imports work. So just how to create a chart in the Vaadin way, just Java. So not really interesting for this talk. But if I now actually go and see how this application looks like, this is what comes out. So this is the coming through, okay. But that's kind of how the Vaadin programming looks like. So this is the way I built the next thing that you're going to see, the dashboard showing the real-time data as well. Same stuff here. And one cool feature I'm using in this example is that if the data is backend is either slow or I have to wait for something to come in, I want to use the server push. So true server push, WebSockets or something similar. So let's put that up as well. And let's actually remove these and simulate that I have a slow backend now with threads. So 2 threads fired up for the data, and the top data, it's like this one. So I'm using data API that is just slow, and then when the data is coming, I lock the UI and I push the data in. So let's see how this actually behaves now. Where is it? So the app actually came right in, but now we're waiting for the backend to finalize, and it comes when it's ready. So this same mechanism is used when I'm actually getting the data from the drone as well. Okay. So that's the Vaadin programming. About everything is Java, also the client side. We use Google Web Toolkit on the client side, so I don't have to do JavaScript if I don't want to. A lot of add-ons, theming engine, I can program my themes, my CSS files as well, and you can do hybrid apps for mobile world if you need to, and the future is So next up, what's going on inside the actual cloud? So there I have a Vaadin app, just a similar one that you just saw, that's the taking basically in the data processing. So it's subscribing to the MQTT messages. And then whenever the data comes in, it uses the same server push to give it to the UI, show that. So that's the whole thing there. So the data processing is like this with the PAHO. I just implement an MQTT callback, I subscribe to a topic, and then there's a listener method. And whenever the data comes in, the method gets called. That's all you need to do. Really, really simple. All right. Now, let's see if everything is okay with our demo gods. Okay. Actually, assistants run away. We're going to fly again, so you'll be warned. Okay. So here is the app running in the Plumix cloud. Let's see if the internet is up. Yeah. It would be much cooler to show you something if the internet would be up. Okay, let's still give it a few seconds. My backup plan to show it locally, at least the dashboard. Actually, I have it somewhere. Okay, here we are. Now, start up. Why isn't it starting? Oh, I forgot the Tomcat app on the Eclipse side. Sorry for the hassle. Okay, let's try it again. Okay, something seems to be happening. Okay. Okay, this is somewhat working. This is the local version. The same app is running on my machine here. We can't access the cloud for some reason right now, but let's see with this one. All right, is everything okay? Come on now. Yeah, some data is coming in at least. And it's gone. Almost. Come back, please. Thank you. Some movement. Come on. It's a thing. A bad day for the drone today. No worries. It's just a magnet. Yeah. But anyways, the data is being gathered now. So let's put this up again. Yeah. Is the link still up? No, the link went down actually. Could be easier with the internet here. So let's do this again here. let's try to open it again. Doesn't keep the data. Let's fire this up again. Sorry to keep you guys waiting. If there's a lot of interference, the link just goes down all the time with the drone. A bit of patience. So while we wait, I can tell you guys some facts about the colleague had a drone. How high it can actually fly. And they tried it out. And while they actually did that, they just, shoot it up to the air, and they never saw it again. So then again, you've been warned. Okay, are we now getting something? Internet is somewhat up at the moment. Is it? Now we are. Yeah, for some reason the data is coming in very slowly. I think we're missing most of the data too when going through the whole set. No, it doesn't really give any data. Okay. Okay, one more try. One more try. Please work now. Because the last thing that I really would like to show you guys is the two-way data. So of course I can read sensors, send commands back to the devices. That's, when things get interesting. So I need paint for that one. Okay. All right, it's kind of there. Okay, let's try it anyways. Okay? So, this is the last thing. So what I actually did with the drone for two-way data, I actually implemented in the same app that's running in the cloud in Dallas. There is one view that you got phones or laptops. If you follow that address and the internet is working, and a page that looks like something like that, put in your Twitter account and click the button, and there's MQTT message coming back from Dallas to the room, to my laptop, to the drone, and if it comes through, the LEDs will start blinking on the drone. So, if the link is up and working. So, if someone would like to try that out, let's put this here. Hey, something's happening. Something's happening. Let's put this airborne. Hey, let's stop blinking. Someone is coming through with their mobile phone at the moment. Yes, this is working. Awesome. Finally. All right, let's celebrate that a bit. Yes. Woo! So let's see, Twitter, Vaadin drone. So this one has its own Twitter account. So we can see here that Cartben, where is Cartben? There, awesome. You made it to the list. And what is this? Torque, Ilder, there you are. Yes, you got yourself a tweet from the drone. Awesome. So this actually worked. The dashboard didn't work, the connection was too slow for that, but these small messages to actually initiate the LED blinking, those came through just fine. That's awesome. All right, one more time. Here we go. And it's down. Awesome. What a troublesome talk with the internet connection. But anyways, that's all I have. I have used all my time. I am here afterwards for all the questions you might have. And thank you for your attention. We made it. Yes. Remember the rate, despite all the obvious that happened.
the speakers?
As long as you don't throw it, I take it.
Okay, no problem. Wait a second, just stay in line for the moment. So actually last year we asked the speakers, all the speakers, to be here in the morning at 9 after the reception, and we had some complaints. That, well, you know, that's not fair. And also some guys that were not so, well, crystal clear to explain the content of their talk. Are you ready? Ouais. Je suis pas branché. Ah, lui, d'accord. Ok. Merci.
Mais c'est les speakers pitch en premier, ça marche.
Ouais, ouais. Ok.
Mais pourquoi ça fait ça?
So let's start with the speaker pitches. So 10 seconds. Well, hey, let's say 15 seconds, because 10 seconds it's really, really too short.
At 15, and then I said,
Yeah, they beep after 15, and they have 2 seconds to finish.
Okay. No, you go.
Okay, so you are the first one.
I can't catch. Boris Adrian, tomorrow morning, 9:15. Why research programmers and programming scientists should get recognition, and most importantly, training. And I'm going to show some ridiculous examples of my coding skills.
Hi, I'm Natalie. Tomorrow I will be speaking about application user interfaces, and if you think that usability is about applying a bunch of principles and rules, then come tomorrow, 10 Argos, because Dave and I have something to tell you.
Interesting applications of modern merging, tomorrow, Argos, 11:05.
Hello, I'm Akos, tomorrow 10 at Diamant. If you don't like when guys go out to have a coffee break or just smoke due to the fact that the computer is that you are processing on transforming, come to see us and I will give you a talk about incremental transformations. 10 at Diamant.
Hello, tomorrow 11:05 in Diamant, I will explain why no longer needs to do any null pointer checks and why we have been writing much less code in general lately.
Hello, I'm Nicolas, and tomorrow at 10 here I will speak about OpenHub, aka Eclipse Smart Home, not from a developer point of view, but from a very enthusiastic user point of view, with using it in a Living Lab platform.
Hello, I'm Santan. Tomorrow morning at 9, just here, we're going all together pair programming, modifying the same file, Java file, for instance, with Eclipse Che, Eclipse Orion, Eclipse Flux, and Eclipse IDE. See you tomorrow.
Hello, I'm Pierre. Tomorrow morning at 9, I will try to explain a bit more what is exactly Cura and how we can use it quite easily to implement a smart IoT application connecting a Bluetooth low energy sensor to the cloud. So you're welcome.
Hi. So tomorrow I'm going to give 2 talks. So I guess I got 20 seconds. So first talk in the morning, I'm going to speak about model execution. How can you bring simulation into your modeling environment? Basically, we're going to make some virtual LEDs blink just like it would blink on your Arduino. Then in the afternoon, I'm going to present the new and noteworthy of Series 3.0. So I'm going to speak about usability regarding diagrams and large model scalability. Thank you. See you there.
Thank you, guys. So, Ignite talks. So I think that initially it was an idea of Benjamin or Michael, or both, Benjamin. So we did that since first year, so that's third year now. And last year I was in charge of it and I did it very badly. So this year all the slides are on the machine, and the principle is that it runs automatically. And I'm coming to that. I'm coming to that. So the principle is that you have to describe your topic in 20 slides, and so that's something very fast and yeah. And actually, last year, the guy who made me screw up with the thing of the Ignite talks was Olivier, and we gave him a second chance because he always talks about nice topic, but that's your last chance too. Okay, so first one is OSLC with Mathieu.
Yes, it's me.
Go ahead, Mathieu.
Okay, so you all know that it's a difficult exercise. Where do I start? But I can cheat, I can talk without starting the slide. No? Okay. Okay, so yes. So my name is Mathieu Elbois, and I'm a software engineer for Thales Corporate Engineering. And I will talk to you about OSLC connectors, why do you need it, and how to do them. So there is two news. There is a bad news. I won't be able to make a demo because I don't have a lot of time. But the good news is it will only last for 5 minutes. So if you're not interested, don't worry. So OSLC, what is it? The goal is to do data and tools integration with open specification and in using the web technologies like REST and RDF. You may be using OSLC without even knowing it. For example, the MyLink client could be considered as a change management OSLC consumer, and you can have adapters on top of Bugzilla or Jenkins and so on and so on. Okay, let's just take a simple scenario. You have a wonderful workbench to do system engineering, like Capella, and you want to link a system function to a requirement. How to do that? With OSLC, you would basically expose one resource for your system function with some RDF stuff, and one resource for your requirement with also some RDF statement. To do that, you will have to write two OSLC providers or consumer, one for architecture management on top of Capella, and one for the requirement tool, for example, WorkCycle. But there is a lot of functionalities in OSLC, and you would have to do a lot of functionalities to implement them, like dedicated UI, authentication, queries, and so on, and so on, and so on. So, to help you do that, there is Eclipse Leo, which an Eclipse project, of course. It's an SDK to help you write some consumer and provider, mainly in Java, but there is other languages. There is also example, reference implementation, and even test suite to test your consumer. But yet again, you have a lot of code to write because you have a framework, but you have to write your own connector by yourself. It's a lot of work. So the idea was to provide some tooling to help you define a model representing your connector, to provide also a generator, which will help you to, in fact, generate the code of your connector. There is some benefits to that because you can validate, of course, your definition of the connector. If someone improves something in the generator, you will have an improved connector. If some spec is changing, you would just have to regenerate your connector. But you still have, in fact, to write specification. And in the case of Capella, there is a lot of meta models and things to understand. And so we came up with some accelerators, which will automatically, and you can modify it later, but will help you, according to the meta models, to define the specification. But after that, you would still have, in fact, to write some code in the connector. For example, you would have to load your models by yourself, unload the models, map the EMF queries to the OSLC queries, and so on and so on. So to do that, once again, the tooling is helping you, for example, to make some dedicated UI more simple according to the meta model or the EMF model. After that, you can see that there is also other benefits to this approach. For example, it will also work for some viewpoints, which are in fact Capella extension with new DSL, or you can use this tooling also for other modeling workbench. Of course, you just have to define and generate. The status of this work, yes, there is, my boss is not here, so I can say it. There is still a lot of work to do, like documentation and some Gerrit things to approve, but it's in a good shape. This work was done mainly by KTH, Thales, and Atos in some several European projects, and is provided, in fact, in the Eclipse LIO project. So if you have any question, you can contact me or Tristan from Atos. He is there, I think. Or you can ask Google, which is your best friend, I think, if you want to know how to generate an OSLC connector. Thank you.
Thank you. I think you don't really need to hold the bottle for the whole speech. That's okay. That was just for the speaker pitches. So next one is...
Je peux l'ouvrir.
Yes, Equinox by Serban Constantin. Where are you? Here you go. Bon.
Ouais, c'est bon. Il faut juste
So,
appuyer là quand tu es prêt.
Yeah, yeah.
Okay.
Okay. So, hi everyone. I'm Serban Constantin. I'm a product engineer for Freescale Semiconductors. What we do basically is we manufacture integrated circuits for auto, communications, consumer electronics, and we also write enablement tools for our hardware. This is the CodeWarrior IDE. It's an Eclipse-based, and it's optimized for Freescale hardware. This basically means that we take Eclipse and on top of it install all our stuff. This means that we rely a lot on customizing the whole flow of features and so on. Basically, we have one base stack on top of which we apply custom different branches. So we have custom compilers and custom and so on, but everything is done via install new software, so we're all using the Equinox P2 provisioning. This means that in order to fully take advantage of all the stuff we have to do, we had to write some custom updater actions. They are mainly done to extend the provisioning platform, and due to custom requirements of having binary data outside the folder and so on. So the main one, the first one was Freescale install. This was similar to native P action. If you've ever installed the feature, you know how that goes. Only we place binary outside of Eclipse. We do some file checking overwrite, and we first copy the binary to a temporary location and then move them to the destination to make sure that everything is safe and we can revert. After that, people told us that, hey, due to all the checking and so on, your install action is a bit slow. So we came up with the copy action, which is an unsafe one because it basically doesn't do any file in use checks. We basically take the data, dump it in the location, and that's it. Usually, as projects go on, people start using your stuff, and then they come with requirements like, hey, I installed your feature, you put your data on my computer, then I said, I don't like that. So I hit uninstall, and oh, look, your data's still there. So management comes and says, OK, you need to make a remove action to delete everything. We also have execute actions because we have a lot of binary and custom executables. So we need to run different provisioning scripts and so on. These are platform agnostic, meaning we can run them on all supported platforms. We do all kinds of verifications for exit codes, and combined with the install and copy, we can do complex deployments. A lot of our configuration stuff is based on XML files, so we also extended P2 to have actions to automatically merge XML files. So we basically provide a patch set, and we tell it, OK, this is the new content. You need to add it to the file, and it automatically manages to do that for us. After that, some people decided that, hey, we know that some stuff isn't necessarily locking, but we would like to know if it's running in the background. So we had to design a mechanism to check if a process is running, and if it's running, we need to tell the user, hey, it's running. You should probably close this instead of going on with the install. And this was made so that we have full control over the background of the system before doing our custom deployments. Speaking of custom deployments, this is a completely weird case specific to, I guess, only us. In case you have two separate Eclipse installs, but you want to keep them in a sync, you need to deploy plugins. So say I install a piece of software in one of the Eclipse installs, we want to automatically update the other one as well. This was done by taking advantage of the reconciler drop-ins directory and running some scripts in the background to notify the Eclipse that the platform has changed in both environments. And that's about it with extending P2 for fun and profit.
Thank you. The next Ignite talk is Fuzzy. Thank you. Antoine Thomas of Bonitasoft on gamification. Donc ça va aller. Faut juste appuyer là.
So hello, I'm Antoine Thomas, so I'm community manager at Bonitasoft. I'm also Ubuntu Studio co-founder. So in this presentation, I will speak about how you can implement some gamification into a community or for your community or your application. So I will just use the example of a famous sport, so soccer or European football. I will demonstrate how Stack Overflow is using that, so I guess you all use Stack Overflow. And so if you look at the stadium, on the center you have the stars, the leaders. So actually the people that all the staff on the border of the field are training and take care of. So you can think as the staff, as the community managers of soccer community. And all around you have people who are actually just watching the game. So it's a huge amount of people, not only in the stadium, but also watching the game on TV. So if you look at people who are not professional, but very active in the community, you can create rank between them for they have the latest t-shirts, they pay cable TV to watch the game, they go to the stats, they have a lot of knowledge. It creates a kind of gamification between them. And the second part of community member in the soccer game is people who really play. So people who really play, it starts with little kids in this game. You have a complete system around to identify who will become a star. It starts with local clubs, regional clubs, professional teams, but you have also the local championships, all the cups and medals they get. And this system helps the staff, the professional teams, to identify the stars. So how can we place that on a famous community like Stack Overflow? Who use Stack Overflow here? Who is going to Stack Overflow? Who is actually contributing, writing stuff, question and answer? So that's the point. Nearly no one. So most of people are actually just watching the game. They come to Stack Overflow to watch question and answer, and we call them lurkers. So that's the part very difficult to identify. And Joel Spolsky, Stack Overflow CEO, says that actually people do not participate more because of the gamification. It just helps to identify who are the leaders, who plays the game, who are contributing. So this is my profile on Ask Ubuntu. It's another Stack Exchange platform. And it helps to understand what is the business model of Stack Overflow. It's recruitment, human resources. So their job is, they earn money by displaying job offer on the right column. And all you do when you are active is attract people who are not. So if you want to create a game on your community, first of all, it's easy. Highlight the leaders. You can create points and badges based on basic action like content creation. Don't forget to create negative points count sometimes and special right access based on amount of points like moderation rules, edition, stuff like that. And special stuff like providing them with gifts and blog interviews. The difficult part is to identify lurkers. So if they are connected, login in your website, you can use badges. For example, when they view 50 questions or 100 answers and stuff like that. But you can also use Google Analytics or special system based on cookies and plug that to your lead gen, because actually most of your customers are lurkers. So your sales representative will like to see what those lurkers are looking for on your community. The last step, of course, is to add fun. So how it goes? Create lists so it's easy to understand who gets a badge and create a great user profile with detailed activity and stuff. It has to look really great and fun. Add some what the fuck stuff. It's easy. Just do a kind of brainstorming with some alcohol and cool guys, and you will find some really good ideas of crazy badges to add. Again, it's not about just only lead gen, but keep that in mind. So at Bonitasoft, we are doing that on community.bonitasoft.com. So we are doing that with a Drupal distribution. It's PHP. I know that it's not your stuff at all. But if you want to try it, contribute, you're welcome. So already, we will migrate on that this summer. So thank you very much for watching.
I know.
It will be better if it works front. No. Oh no, the screen.
Yes.
Oh, I'm sorry.
No email, no emails. Okay. Okay, so this is an I talk about again Gen Model add-on. This is a project that could use that you generate with EMF. So this tooling, I wrote this tooling to to apply good practice for model-driven development. Actually, there was an interesting article written by Sven with the leader of Xtext, who said that if you want to manage your generated code, you should not mix your generated code or your overridden code. So this is one of the first principles. Another one is that you should not deliver your generated code. You should generate it on the fly when you get the project. Of course, if you have Java code, it's better to override the code using inheritance. And you must also, so that's other issues like to have clean code because you will have to debug it and you have to test your your. So I will focus on the part of the on the separation of the value problems with that you can application, but usually people override the code using the generated annotation. So it's a little technical, but if you don't know EMF, I know that you don't know this stuff, but it's for EMF users. And you have also some tooling like mine, for instance, that can help you to identify the overridden methods, for instance. But if you do that, you mix everything, and it's not always easy to know how to deal with your code. So actually, if you want to apply these practices, you should folder, you should create a new EMF factory, you should extend the factory override extension point, and then you should write a class and an interface for each class you want to override. So that can be a lot of work if you have a lot of class in your model. So I started a project to help you to generate this code. This is hosted on GitHub on this URL. So if you just search on Google Gen Model Add-on, you will get this page. And there is an update site to install it. So actually, this tooling will generate for you in the source directory. You will have the templates of the code you should have to apply these best practices, and all this code inherits from the generated code generated by EMF. So in this case, you have two separate folders. If you want to try it, there is an update site that you can download it from the main page of the project. And when you restart your Eclipse, you will have an additional menu, generated dev, where you can generate the derived source folder. Actually, it will analyze the gen model file that you have selected when you open the menu. It will find the values you have set inside this model, and then you can set here the values you want to have for your specific development folder. So in this example, I just renamed all the model classes, the generated model classes with an M. So when you launch the application on this project, for instance, where you have an inheritance, you will get, so I cannot enter in details, but you will get exactly the inheritance you are expecting, even if you override some interfaces. And something interesting too is that you can keep in your code the usage of the project factories, over the X factories you have to use when you have an EMF project, so with instance. So this is exactly the same code when you use it because the factory has been overridden. 15 seconds, so that's okay. So the URL of the project, and if you have any question, you can ask me using this email. So thank you. 4 seconds.
Thank you. I was about to run to unplug your laptop. Okay. So, as I said before, today is the day for the Mars release, and we have the chance to have Wayne with us. So, Wayne Beaton is the director in charge of open source projects at the Eclipse Foundation, and we decided to give him more than 5 minutes because we think it's important for the community. And so, Wayne, go ahead. No?
Okay, no, good to go. All right. So, Mars has already been released. Before I begin, I gotta let you in on, I thought I was going earlier in the day. So we'd arranged that I'd have all these live feeds of people working on Mars, and we get you to actually see them push the button that causes the release. So I need you to pretend that the release didn't happen. I need you to pretend it's a little bit earlier in the day, and I need you to pretend that you believe me that this is a live feed. Here we go. So this is a live feed from the Eclipse Foundation offices. This is webmaster Matt working away, and that button there on the table is the button we push when it's time to do the release. Now, when this button gets pushed, and we have to wait a few minutes, we're still about 15 minutes away from the, uh-oh. More volume, please. More volume, please. Okay, so we should be, we're a little bit too early. We're not quite ready to be pushing out the bits. I actually have some people standing by live. I hope that they're ready. Oh gosh. Yeah. More volume, please.
You can do this. You're still Eclipse Lynn. You're good enough. You're a marketer, so it doesn't matter that you're not smart enough. And yesterday, when you tweeted that photo of your breakfast, 2 people liked it. What the? Is this thing on? Am I live? No!
All right, so it looks like Matt has recovered that. Hopefully they're undoing the damage that was done by Eric hitting the button, and I guess it's time for me to start my talk. So Eclipse Mars is our 10th simultaneous release, and we couldn't be more excited. It's 10 years of shipping on time, which I think is pretty amazing for any organization. It is a testament to the dedication of those involved. I'd like to sort of just make a shout out to David Williams, who does an incredible amount of work on preparing the simultaneous release and making sure everything gets put together. Marcus Knauer, who puts the packages together. These guys together do a great deal of work for the community and deserve a great deal of respect for that. 79 different projects joined the simultaneous release. 65 million lines of code is our estimate. We had 3 new projects join, 4 dropped off. The new projects, SWT Bot, FX Eclipse, RCP testing tool, Time, Trace Compass, OOMPH, the Lua development tools were new this year. We had a lot of committers. One of the things I find is interesting is we wound up with 352 contributors. These are non-committer contributors who almost matched the number of committers we had involved. The contributors accounted for more than 4,000 different commits against the repository. On average, each contributor actually contributed 4,000 commits. Ed Willink from the OCL project committed the most number of commits. Ika Stepper, who is here, was, I think, 3rd place in terms of our in terms of the number of commits. So we've added Docker tools to Eclipse. Max Anderson did an excellent talk about that a little earlier today. So the idea is you can control your containers and your images from Docker from directly within the Eclipse environment. I apologize for the quality of the graphic. Apparently, I did a poor job with that. We also did a lot of work this time on an installer. Ika Stepper, Ed Merckx, who are around here, did a lot of work here. It's actually kind of amazing when you think about it that we've gone as long as we have with Eclipse without actually having an installer. So this is new technology that we're pretty excited about, and we want you to try it. I'm particularly excited about the advanced version of the installer, which lets you actually realize an entire development environment, including Git repositories and Myelin tasks, and a target environment. So it's great stuff. I invite you to take a look at the installer, look at the advanced stuff. There's also some preferences propagation. This is a long-standing issue with developers that use Eclipse. I have preferences. I want those preferences to be global. You can now do that with the preferences recorder. It records preferences as you change them and then propagates them to other environments as you start them. So you can tune your environments fairly quickly. One of the things that I find is neat about that is it's made me start thinking about my Eclipse environments as far more transient. I make them and dispose of them as I need because, of course, the preferences come along easily, basically for free. We also have some tools for Cordova. Cordova is the open source PhoneGap. This is a new project. There's some cool stuff in there. It's basically building phone applications for iPhone, Windows Phone, and Android, using JavaScript, CSS, and HTML. It's, again, I've played with this just a little bit with the Android stuff, but it's all pretty solid and good. Gradle support is actually not technically part of Mars. It's released at the same time as Mars. Unfortunately, the BuildShip project didn't come to us quickly enough or soon enough to join the actual simultaneous release, but you can add great Gradle support to your Eclipse IDE directly from the Eclipse Marketplace. You can actually drag and drop the Gradle support directly from the new and noteworthy documentation or from the marketplace itself. Another feature that we've added that I think has been pretty handy is the automated error reporting. When an error happens in Eclipse, I know that everybody, when they detect an error or see some error in their log, they create a bug report. What we do is we do this for you automatically. It takes very little effort from you to generate that report, and it helps our developers immensely. At this point, we have fixed 277 bugs that we wouldn't otherwise have known about because of the error reporter. There's a lot of different updates to the platform, and actually this is the reason I have my book, because there's so many of them I couldn't remember them all. So we have new Java 8 quick fixes, pardon me. The code recommenders is on by default. Constructor completions, override completion. We have a new Java code formatter, improved flow analysis in Java. JUnit view usability is improved considerably. Lots of debugging and console improvements, including word wrap in all of the consoles. There's a Java 9 beta available from the marketplace. If you're going to use that, you actually need to have a Java 9 JVM running underneath your Eclipse. Tomcat 8 support, JSP and CSS editor improvements. Automatic updates are on by default. We're looking for that interesting deluge against our servers. We'll see how that goes. Improved performance for updates, improvements in the dark theme, nested project view in the Project Explorer, a new launch bar. Text search has been sped up. The one that I've been holding my breath waiting for is the print button is now hidden by default. Max heap size has been set to 1024 megabytes. There's been some great strides and improvement on GTK3. The Mac OS distribution is now an actual application bundle, so it acts like a proper Macintosh OS X application, pardon me. Git flow support. Project import directly from Git, Git config Java work variables, and CVS has been removed from the packages. We now return live to the Eclipse Foundation office, and Matt, who is putting the final touches on the Mars release and getting ready to, with great excitement and ceremony, hit the magic button that pushes out the Mars release.
Congratulations, Eclipse, on your Mars release. Amazing work, and of course, another fantastic release name. Eclipse Mars 2015, hashtag crushing it. Now, how do I turn this thing off?
Hey Wade, you've caught me on the back straight of Spokane Raceway. Can't believe it's been 10 years in Eclipse release to awesome. Congratulations. Oh, hey, I gotta go, man. Keep it up, Eclipse.
That's Jeff McCaffer, a longtime committer.
Congratulations to all the members of the Eclipse community.
Kim Horn, a longtime platform committer.
Mars. It's been a great 10 years, and I look forward to seeing the next 10. Bye.
Huge congrats to everybody in the Eclipse community on the 10th simultaneous release.
Hey, Eclipse
Jimmy and Sonia.
I hear you're shipping Mars this week. Cheers!
So those are all people who've been important parts of our community and have moved on to other things, but they still love Eclipse. They're still involved a little bit. But anyway, that's all I have. Thank you, everybody, for attending. Thank you for helping us make Mars great. And please enjoy Mars. And get an Eclipse account, sign a CLA, report bugs. We need to hear about them. And submit patches, too. Patches are cool. Thanks.
Bravo. Okay, so I think we are done for today, but there is the last thing is that we have just an hour to go to the Tantina. So it may be more than enough. So La Tantina de Burgos is the place for the reception tonight. That's a famous tapas bar in Toulouse. And so you can either take public transportation or you can walk there along the river. That's only 30 minutes away. And Roxanne will certainly be outside with maps. If you need maps, there are maps on the registration desk, just and on the website. Okay. So I hope to see you there, because that's well, you know, coming to the conference is also a lot about networking and meeting people in real life. So I think that's a nice place, and I'll be happy to meet you there. See you soon.